Night gathers like velvet over a spiral city of suns. The camera of the mind drifts outward, slipping past familiar constellations, lifting above the bright river of the galactic plain, until the Milky Way becomes a snow-white bridge arcing across a black gulf. The stars thin. The interstellar clouds loosen into faint gauze. What once felt infinite begins to look local. A quiet threshold approaches. Not a cliff, not a wall, but a change in the airless light. A hush that invites attention. The question rises without a voice. Where does this home end? At the heart of the disk, a black hole turns in patient silence, shepherding a chaos of orbits. Far from that heart, the spiral arms sweep like frost against a window, each spark a sun, each sun a world of chances. Yet the edge, the supposed edge, refuses to sit still. The boundary behaves like mist over cold water, always forming and unforming, always shifting with the faintest breeze of new data. He moves past the last clear lanes of blue young stars, and past the elder red beacons that orbit high above the plain. Gravity is still at work here, though it wears a thinner cloak. The light is scarce, but the story is not. A field of faint dwarfs lingers like lanterns at low tide. Some are claimed as kin by their motion. Some only pass through with shy indifference. Streams of stars unwind across the dark like pale handwriting, clues to ancient mergers buried under eons of drift. Each strand suggests a time when the Milky Way was larger by one story, and then larger again, swollen by feasts on smaller companions. The boundary remembers every encounter in the language of orbits. The camera reads that script in the cold light of the halo, where starlight fades and the unseen begins. Here, the light is a rumour whispered by globular clusters that swarm like winter bees. Their ages are old beyond easy reckoning. Their motions draw invisible curves through a volume that is less a shell than a breathing volume, an enormous lung of mass and time. He lingers near one, listens in imagination to the close-packed cores and the fragile atmospheres of ancient suns. The cluster continues its long ellipse, loyal to a centre it will never meet. Even loyalty is a form of gravity here, a vow written in speed. The medium changes again. Gas, so thin that deserts would seem oceans by comparison, spreads across hundreds of thousands of light years. It shines only when provoked, and then only by taking light from elsewhere. If sight were a little sharper, the view would reveal a dim scaffold of elements forged in vanished supernovas. Metals drift like pollen. Hydrogen flows like rain between follies of potential. The wind is not wind, not really, but an exchange of heat and momentum in a near vacuum that still manages to sculpt. He senses a pressure that is almost nothing, yet adds up across deep time to weather the outskirts of a galaxy. Far below, the galactic disk rotates like a slow coin. Above, the extragalactic darkness holds its breath. Between them, the frontier trembles. The mind wants a line, a clean curve to circle on a map, a final radius to print in quiet italics beneath a figure. The universe offers instead a family of almost edges. Gravity says one thing, light says another, gas adds caveats, and motions complicate the rest. This is not a failure. It is an invitation to walk carefully, to let the boundary declare itself in layers, to accept that a coast drawn by tides will never be the same on any two nights. He drifts farther. The star counts fall to nearly none. Then, as if refusing to let the darkness win, a solitary blue runaway stitches a bright stitch through void. Its speed is a story about something violent that happened nearer the centre. The star carries that memory past the fragile periphery and outward, into an environment that will test every claim the galaxy makes upon it. The boundary becomes a gate with hinges of probability. Some bodies pass through forever. Some are turned back by a reach that is weaker, but still not done. There is a sound here that is not sound, a pressure of silence that heightens every glimmer. Photons that began near the core arrive with the faintness of rain on stone. Photons that come from other galaxies intersect with them, a quiet crossfire that marks no wound. The frontier is not empty. It is a conversation between places that think they are separate. The cameraman of thought, weightless and patient, floats in the slow collision of messages. The cosmos writes letters in every direction. The boundary is the place where a reader realizes there are other alphabets. He looks back. The Milky Way is no longer an arch filling the sky. It is a small, luminous bruise on the dark body of space, tender where interactions once pressed. The sight makes the heart feel both large and small at once. Large because a creature has learned to imagine this distance. Small because the distance does not notice the imagining. That doubleness carries its own calm. There is comfort in the fact that borders in nature seldom behave like fences, that the world allows for gradients, that belonging can thin without ending. On this horizon, theories will later arrive with instruments in their arms. For now, there is only the raw astonishment that a home can be boundless in one sense and bounded in another, that a family of definitions can coexist like overlapping shadows at dusk. He tests the night with a thought experiment. If the galaxy were a city, then the boundary would be the last porch light on the last street, and beyond it would be fields whose ownership is argued in township ledgers. The metaphor does not last, but it reveals a truth. Arguments about edges are human, but they are not only human. Nature negotiates too, through forces that never sleep. He turns to the dark again and feels a current that seems to pull outward. It is not a river. It is the geometry of expansion, a gentle stretching of the coordinate grid that has no sound and yet rules the scale of faint motions. Even here, inside the reach of a great spiral, that quiet expansion has a say. The galaxy is a local rebellion against it, a knot of gravity that refuses to drift apart. At the edge, the knot and the drift parley. Every particle is a vote. The count is close, and it changes with radius, with temperature, with time. Shadows glint. Dwarf companions glide on long leashes. Some are destined to be unspooled into streams. Some will keep their dim hearths. He watches them and understands that a boundary is often written in the fates of the smallest members. The powerful define the center, the fragile reveal the edge. A tide line is best read where shells accumulate. The halo carries its shells as stellar debris, as cold gas clouds, as orphaned clusters, as the collective whisper of mass that refuses to make stars at all. If the disk is a song, the outskirts are the breath between verses, the pause that makes the melody matter. The imagination lifts one more increment. The galaxy finally looks like a lantern hung inside a larger darkness, with soft light bleeding into a fog of matter that human eyes cannot see. The lantern image comforts only briefly, then it instructs. Light leaks, but gravity grips. The interplay writes the profile of the edge. This profile is not an outline on paper. It is a set of behaviors that become more likely or less likely as space widens. Slower stars return. Faster stars escape. Cooler gas condenses. Hotter gas wanders. Patterns emerge from these options. The boundary is the place where the options change their odds. He holds there, as if on a balcony beyond a cathedral, and lets the vista rearrange his sense of scale. The stars of the disk are worshippers. The bulge is the choir. The halo is the quiet between notes that allows the sacred to be heard. No voice speaks, yet something like a blessing touches the scene. Not a verdict, not an end point, simply a recognition that mystery can be whole without being solved. The edge is not a puzzle piece that snaps into place. It is a margin where understanding grows legible. A final glance returns to the glowing city of the Milky Way, now small and entire, yet never truly enclosed. The frontier waits with patience. It has waited for billions of years. It will wait for instruments, for maps, for better eyes, for kinder questions. In the silence, even patience becomes a story. The boundary tells it from both sides, with equal grace. Maps begin as acts of faith. then harden into lines that the next generation must soften again. In the quiet rooms of early astronomy, that softening began with a patient habit. Count the stars, sort their brightness, place them into a pattern that resembles a city plan. Jan Oort would later thread rotation through such plans, but the first sketch that caught attention belonged to Jacobus Kapteyn. He lived far from the enormous observatories of California and Chile, yet he assembled a universe of star counts from photographic plates sent across oceans. What emerged on his graph paper looked like a flattened swarm, a lens of light perhaps a few tens of thousands of light years across. The sun sat near the middle like a lamp on a parlour table. The map felt reasonable. It felt comforting. The comfort concealed an error. The error did not come from his skill. It came from dust. Between the stars hangs an ocean of carbon grains and complex molecules that dims distant light with patient cruelty. Kapteyn assumed space was clear. The consequence was a galaxy that seemed smaller than it is. Yet even in its limitation, his model taught a crucial habit. A galaxy could be measured using statistics, not only spectacle. The boundary might be approached with counting, with inference, with a disciplined kind of humility. In the American Midwest, a brilliant observer named Henrietta Swan Leavitt found a different handle on distance. She studied a population of pulsating stars in the Small Magellanic Cloud. Their brightness rose and fell with periods that matched their luminosities. Short periods belonged to faint stars, long periods to luminous ones. This relation offered a ruler that could be carried across the sky. A Cepheid would tell its true wattage by the rhythm of its light, and from that wattage and the apparent brightness, a distance could be teased out. The boundary of a galaxy could now be pursued not only by counting the crowd, but by listening to the clockwork of certain members. Vesto Slipher added a second trail. He pointed spectrographs at luminous spirals and measured recessional speeds that were startling for his time. Spectral lines were shifted far to the red, implying velocities of hundreds of kilometers per second. The spirals were not clouds drifting in a nearby yard. They were something else, something with heft. Yet their distances remained unclear. The boundary of the Milky Way still seemed able to corral them, at least in debate. Harlow Shapley stepped into this uncertainty with a simple and profound choice of tracer. He mapped the sky positions and distances of globular clusters, those ancient spherical swarms of stars that hover in the halo like frozen fireworks. By measuring the variable stars within them, he found that the clusters concentrated in a region in the direction of Sagittarius. The center of that concentration could not be the Sunday. It lay tens of thousands of light years away. The Milky Way was larger than Kapteyn had drawn, and the sun was demoted from the quiet center to a suburb with a view toward downtown. The boundary expanded in one stroke. The geometry of belonging shifted. New Mexico hosted the echo of this shift in a famous public argument. The Great Debate set Shapley against Heber Curtis. Curtis defended a relatively small galaxy and argued that spiral nebulae were island universes, separate systems altogether. Shapley insisted on a large galaxy that contained those spirals. The auditorium air carried more than rivalry. It carried the discomfort of losing human centrality. The debate did not end the question. It staged it as a necessary drama. The chalkboard became a shoreline map in which every mark seemed to imply a philosophical tide. Then came Edwin Hubble, with the newly mastered Mount Wilson telescope and Leavitt's relation in his pocket. He found Cepheids in the Andromeda spiral and in other nebulae. Their periods betrayed distances that were too large for any structure inside the Milky Way. The spirals were galaxies in their own right. The boundary of home emptied of scandal and became a straightforward fact. The Milky Way was one city among many scattered across a dark continent. Mystery did not disappear. It acquired scale. This expansion of context altered the meaning of a boundary. The edge of the Milky Way could no longer be confused with the edge of everything. The map had to show a local limit, and then a second frame that admitted neighbours, currents, and space between. Photographic plates, once pale grey scrolls of grain, turned into tomes of evidence. Variable stars lined their margins like footnotes that changed the thesis. Globular cluster positions became arrows pointing away from a provincial vanity. Even errors found their use. Kaptein's clarity was repurposed as a caution about dust. Shapley's argument served as a reminder that a measured centre is not necessarily a moral one. Hubble's distances normalized a new humility. In this arithmetic of perspective, instruments behaved like protagonists. The 60-inch and the 100-inch telescopes on San Gabriel peaks pulled faint smears into resolvable citizens. Spectrographs slit starlight into narrow rainbows and laid them out for inspection, like old receipts that hold the truth about a city's budget. Cameras learned to sit for long exposures and soak the night of its secrets. The observatory domes felt like patient lungs that inhaled starlight and exhaled numbers that could be transformed into radii and centres. The dust that misled Kapteyn did not vanish. Robert Trumpler showed in 1930 that open clusters appeared systematically fainter and redder with distance, the signature of absorption by interstellar material. The calibration for distance sharpened. The boundary was remeasured accordingly. What had seemed like a neat lens thickened into a disk with a bulge, wrapped in a dim halo, cut by lanes of obscuration like rivers through a delta. The sun held a position offset from the true centre and lived a little above the midplane. Even small offsets mattered. They restored texture to a map that had been too polite. The new geometry invited dynamics. Bertil Lindblad and Jan Oort teased the galaxy's rotation from the motions of stars. Differential rotation replaced the solid wheel. The galaxy turned like a record, with subtle warps and speed gradients. The edge was not a bald cliff. It was a regime where star density and orbital behavior changed character. A cartographer of such a place would not ink a single outline. He would shade and annotate with care, understanding that an edge defined by light might disagree with an edge defined by dynamics. In the classrooms that absorbed these results, a generation of students learned that the sun occupies no balcony seat at a cosmic theatre. There is no privileged viewing box. There is only a location with coordinates and a velocity. The authority comes from data. The romance survives in how the data rearrange wonder. A first boundary became a lesson in method. Find measurable traces. Tie them to physics. Accept the limits of your instruments. Let new instruments rewrite your borders without shame. The photographs of Andromeda from this era look modest by modern standards, yet the modesty hides a revolution. Each resolved Cepheid sat like a lit lighthouse on a far coast, blinking a message not in Morse but in a rhythm of radiance. Period tells luminosity. Luminosity divided by apparent brightness tells distance. Distance converts a smudge into a city. A city implies a nation. A nation implies a world system. The mind climbs those inferences as if climbing a bell tower and then looks out across plains that are no longer rumours. Dislodging the sun from the centre did not harm its warmth. It freed the imagination to accept that significance does not require centrality. A boundary can be true without conferring importance, the way a shoreline defines a lake without judging its depth. The early mappers worked within that growing clarity. Their atlases remained provisional, yet they made a habit that endures. Humility paired with audacity. Count, infer, propose, correct, place the line, then invite a better line. When the first atlases of the Milky Way went to press, they carried the grain of glass plates and the smudged fingerprints of human hands. In their pages, the galaxy took a shape that could be discussed in units, not legends. It stretched farther than expected. It set its centre amid star clouds that could be named and pointed to. It hinted at a halo whose light was too pale to dominate, yet too present to ignore. It refused to grant the sun any throne. It learned to be one among many. That learning was the first journey past the parlour wall. By the time the public absorbed this map, language had already shifted. The word universe had split into two uses. In one, it meant the whole of everything. In the other, it meant an island of stars. The second usage retreated, but left a useful memory of how frames of reference change. A boundary can move because the instrument improves. A boundary can move because the concept refines. The early cartographers accepted both motions and drew accordingly. The room falls quiet where the maps lie open. The eye traces the printed disc, then wanders into the white around it. On those white margins, the future waits. The immediate achievement is not a final outline. It is a discipline of seeing. Choose tracers with known rules. Measure their signals. Let numbers unseat flattering myths. The first boundary holds on paper like a shoreline traced by a careful hand. It is real enough to plan a voyage. It is honest enough to anticipate revision. Night unfolds in tiers, and on the farthest tier a revelation waits like a curtain that does not hide but transforms. At first, a spiral city of stars seemed sufficient, a self-contained metropolis turning with its own rituals and seasons. Then the telescope lingered longer, and small smears that once seemed decorative took on character, and character became citizenship. Other spirals appeared, tilted at quiet angles. Elliptical forms glowed with the mellow light of age. Irregular patches freckled the dark like sparks that refused to keep a shape. The sky was not a ceiling. It was an archipelago. That recognition altered the meaning of an edge. No line around a single galaxy could pretend to separate light from nothingness, because beyond the faint rim there were neighbours, and beyond the neighbours there were corridors of still more neighbours. A boundary began to resemble a shoreline, a place where one city faced a strait instead of a void. The strait carried traffic, not by boats or caravans, but by gravity and radiation, by tides that took millions of years to register, by whispers of gas that slipped between systems like fog seeking low ground. He surveys this wider map without haste. The local group gathers around a gentle centre of balance, a handful of large galaxies and a retinue of dwarfs negotiating their futures with patient momentum. Nearby, a cluster glints with the massed light of thousands of member galaxies, a honeycomb of gravitating cores swimming in a hot sea of plasma that radiates away its heat in X-rays no human eye will ever see unaided. Farther still, sheets and filaments arrange themselves into a web, so vast that metaphors fall short. These structures stretch across distances measured in tens and hundreds of millions of light years, and they leave voids between them like amphitheatres of darkness. The shock lies not only in numbers, but in the logic those numbers require. If the sky hosts hundreds of billions of galaxies, then no single system can claim a special exemption from the rules that stitch them together. The rule that speaks most loudly is expansion. Space itself grows with time, like a fabric that gains new threads between familiar ones. Light from receding galaxies elongates into red, its wavelengths stretched as if sound were lowering its pitch over an unending valley. Radial velocity becomes a signpost rather than a storm. The farther a galaxy stands, the more pronounced the shift. Distance and speed coordinate like dancers who share a tune that the universe hums without a source. This tune carries consequences for any border imagined around a galaxy. The expansion does not tear bound systems apart, but it does set a frame for what counts as a broad. Beyond a certain scale, recession overrules gravitational claims. The edge of a spiral becomes less like a fence and more like a beach at the ocean of the Hubble flow, where drift currents play tug with the pull of home. Small galaxies can be detained by a large neighbour. Medium galaxies can form councils called groups. Larger gatherings settle into clusters whose central galaxies act like mares with deep pockets of dark matter. Yet the tide that draws everything outward continues its soft labour in the gaps, reminding every coast that it belongs to a wider sea. He studies a patch of sky that once looked empty through small lenses, then blooms with points when a larger mirror opens its pupil. Each point has history. Some are youthful, blue, and busy with birth clouds. Some are faded, their gas spent long ago, their populations dominated by stars elderly in demeanour if not in calendar years. Some reveal bars and rings that speak of past rearrangements. Some are lopsided, scarred by the memory of a close pass or a partial merger. The unfolding becomes an archive. Even silence carries annotation, because the absence of new stars writes a marginal note about heating, feedback, and the hard work of keeping gas available for future generations. The shift from solitude to plurality resets emotional sums that were once reckoned with different units. Ore no longer anchors itself in largeness alone. It learns to rest in pattern, in the recognition that forms recur without repeating. Spiral arms echo across distances that would bankrupt ordinary comparison, and yet each spiral differs in pitch, in bar strength, in the clumpiness of star-forming knots. Ellipticals share a smooth light profile, yet some harbour rotating disks within their old fat bodies, and some hold black holes that glare within full feasts, so brilliant that they drown the starlight that hosts them. Within this library, the Milky Way becomes a volume among volumes, legible, beloved, but not the only story. A boundary gains new functions within such a library. It is a cataloguing device, a way to assign where the authorship of gravity remains confident and where it yields to neighbouring authors. It draws a region where gas tends to settle into a cool phase that can birth stars under the whisper of its own weight, and beyond which the same gas wanders warm and ionized, unwilling to condense. It defines where orbital families remain coherent and where they tangle with tidal invitations. It plays curator to satellites, keeping some close, letting others stray, subject to time that passes in units of billions of years. He feels the quiet pride in how instruments carved out this enlargement of context. Long exposures made with sensitive detectors revealed galaxies so faint that their light had been travelling for a significant fraction of cosmic history. Fields that were chosen for their lack of bright distractions turned out to be cornfields of remote systems. Each faint smudge carried the curve of time within its shade. To see it was to be instructed that the plural of galaxy includes epochs as well as locations, that to look outward is to look backward, and that the boundary of a specific home becomes a set of chapters in a longer book when read within that timeward gaze. Olbers once asked why the night is dark, if the sky hosts countless stars. The answer, in this plural cosmos, becomes one more lesson in limits that preserve mystery. The universe is not ancient without bound, and its expansion dims distant lights with a generosity that permits quiet. Dark remains possible because history has length and because motion participates in the arithmetic of brightness. The very same conditions that allow an archipelago of galaxies to exist also prevent their combined light from bleaching the night into permanent noon. The mind returns gently to the central metaphor that now feels earned. A shoreline welcomes waves, and waves record distant weather. Likewise, the rim of a galaxy receives visitors in slow motion. Dwarfs drift in on eccentric paths, their stars unspooling into ghostly streams. Gas flows along filaments that bear little mass per cubic meter and yet, integrated across immensity, deliver raw material enough to sustain future arms. Radiation from faraway black holes sneaks through the outskirts and changes the chemistry of fragile clouds by degrees. The edge becomes a customs house that stamps passports for arrivals and departures that last entire eras. There is a comfort in realizing that this multiplicity does not dissolve identity. Each galaxy keeps its voice, even when it sings harmony as part of a chorus. The Milky Way, viewed from afar, would present its own cadence in the distribution of its stars and in the spectral fingerprint of its gas. It would disclose a specific rate of forming new suns, a specific mass for the dark halo that holds it in coherent company. It would speak through the timing of its core, where a black hole and its immediate neighbourhood hold a dialogue with inflows and feedback that reaches far into the disk and sometimes out of it. The wider population, though, makes one claim that no single member can deny. Everything belongs to structure that surpasses any immediate edge. Even isolation is a posture within a larger choreography. A galaxy that lives in a cosmic field rather than a crowded cluster still lies on a filament or near a sheet, and its chance meetings and growth spurts follow the affordances that filamentary environment allows. The shoreline image grows practical. Currents are not metaphors alone. They are gas dynamics and gravity, impartially granting opportunity or restraint. He draws breath at the quiet power of that impartiality. The night feels less like an abyss and more like countryside seen from a high ridge, with villages, towns, and cities lit by their own choices, connected by roads that were not paved by them. The ridge is time as much as space. To stand upon it is to see that a boundary, once a parochial concern, has become a vantage point that allows the plural world to arrange itself into a legible scheme. The archipelago does not rob any one island of its garden. It teaches the gardener how the rains come and who else relies on the same river. Light thins with radius until it becomes a rumour, yet gravity remains articulate. Around the bright disk stands a volume more spacious than the mind expects, a vast, nearly spherical hush that holds the city of stars as a lantern holds a candle. He looks outward from the last crowded lanes and sees not emptiness, but a presence that seldom glows. The unseen halo keeps its counsel in the language of motion. The first clue arrives in curves that refuse to fall, plot the speed of stars and gas as a function of distance from the centre. Expect a drop, the way planets slow as they climb away from a Sunday. Instead, the line runs stubborn and flat. Outer hydrogen clouds orbit as swiftly as inner clouds, as if an invisible mass fills the outskirts like a deep lake fills a valley. The luminous disk cannot account for such loyalty. The calculation insists on more matter than light admits. Dark matter becomes a working name for a substance that neither shines nor absorbs, yet discloses its presence through the choreography it dictates. He watches the outermost traces, the cold hydrogen that whispers at 21 centimetres, the faint carbon monoxide knots that sketch the last patches of starbirth. Their speeds carve the same story into the night. Satellite galaxies circle and sway on long periods, their paths bent by a mass that extends far beyond the stellar halo. Even the orbits of ancient clusters carry signatures of a broader pull. The numbers agree to a startling degree. The Milky Way wears a cloak of matter that outweighs its stars and gas by a factor of 5 or 6, perhaps more. The virial boundary that contains this cloak lies hundreds of thousands of light-years from the centre, a radius so large that a traveller with the speed of light would need centuries to cross it. Dark matter is not the only resident of the unseen. Surrounding the disk is a spheroid of hot gas, a corona warmed to 1,000,000 degrees or more, thin enough to masquerade as vacuum, yet massive enough to rival the mass of all stars combined. At such temperatures, oxygen loses many of its electrons and advertises itself through spectral lines that fall in the ultraviolet and X-ray bands. When a bright quasar shines from even farther away, its light passes through this tenuous medium and acquires absorption features that act like fingerprints. The lines betray the presence of oxygen in high ionization states, neon in excited tears, and hydrogen that refuses to stay neutral. Each signature is a breadcrumb that leads back to the conclusion that the galaxy carries a reservoir of hot, enriched gas that circulates between outflow and return. Closer in, a second halo appears, this one made of stars that prefer scarcity to crowds. They drift in wide orbits, with little regard for the neat rotation of the disk. Many are old and metal-poor, time travellers from a youthful era when heavy elements were rare. Their paths draw long ellipses that tilt at many angles, as if stitched together from the remnants of small galaxies that were captured and digested. Streams cross the deep like pale scars, testimony to encounters that never reached a court but left records in the sky. These stars write the autobiography of the halo in elegant, hesitant script. He considers the architecture. The dark component reaches farthest, enveloping all else, a diffuse sphere whose density thins with radius, yet continues beyond the easy reach of stars. Inside it swims the hot coronal gas, bound by the same gravitational well but trading energy through shocks and gentle flows. Deeper still, the stellar halo hangs like a garland of memories. The disk and bulge reside at the center, bright, busy, and loud with new birth. The shapes interpenetrate. No boundary between them is absolute, yet each layer carries its own typical motions and chemistry, as if a symphony had assigned parts for strings, brass, woodwinds, and percussion, and the hall itself were the gravity well. The unseen does not stay quiet in every circumstance. When small galaxies pass through, they shed stars and gas along their tracks. The halo receives the debris and rearranges it into streams that may persist for billions of years. When supernovae in the disk release their energy to surrounding gas, that energy can heat the outskirts and inject metals into the coronal reservoir. When the central black hole awakens for a time and flares with accretion, the outburst can loft material into the higher altitudes where the halo waits to sift and store. The outskirts become an exchange zone. Material leaves, cools, and later returns. The circulation is slow but relentless, a weather system measured in aeons. He steps farther back in thought and considers the origin of the dark scaffold. In the early universe, small fluctuations in density grew under gravity into halos that merged and fattened, creating wells deep enough to capture gas. That gas cooled and settled into spinning disks where stars could ignite. The halo remembers this history in its shape. Concentration parameters and characteristic radii whisper about the epoch when each layer assembled most quickly. The profile of density with radius takes on a form that simulations reproduce with eerie consistency, hinting that chaos in detail still yields order in the ensemble. Evidence accumulates from many angles. Gravitational lensing bends the light of background galaxies, allowing a map of mass that cares nothing for luminosity. The pattern of satellite motions brackets the total pull. The flatness of rotation curves plays a steady theme. Even the temperature of the coronal gas aligns with a gravitational depth that matches a massive halo. The numbers cross-check, each method touching the truth from a different side. No single technique can draw the entire picture, yet together they make denial impractical. What starlight cannot see, dynamics can weigh. He moves his attention to the question of extent. When does the halo end? Several radii compete for relevance. One can mark the distance within which the average density meets a threshold that predicts a kind of dynamic equilibrium. One can choose the frontier where the inflowing matter slows and turns, leaving a feeble shock boundary that can be traced in simulations and sometimes sensed through subtle changes in galaxy clustering. One can draw the limit where the galaxy no longer keeps its satellites bound. Each definition illuminates a different behavior. The halo refuses a single verdict, because edges in nature often form as families of thresholds rather than a single wall. The chemistry offers another map. Gas at the outskirts bears the fingerprints of past generations of stars. Oxygen, carbon, silicon, and iron ride the wind from supernovae into the rarefied heights, then mix with pristine hydrogen that drifts along filaments from regions beyond. The ratios of these elements, measured by absorption against compact background sources, reveal the long and gentle tug of recycling. The halo is not a static storehouse. It is a ledger of inputs and withdrawals, a balance sheet that reveals whether the galaxy spends more material on forming bright youth in the disk than it receives from the wider web. In the quiet of these thoughts, a realization sobers the heart. Most of what keeps the Milky Way together does not shine. Stars are lanterns hung along a bridge of shadow. Gas glows when disturbed, then fades back to near invisibility. The great weight resides in a component that may never yield a photon to human eyes. This does not make the halo less real. It asks for a different way of seeing, one that trusts the testimony of movement, temperature, and lensing. He accepts the terms without resentment. Mystery can be honest. The halo does not merely contain, it shapes the fate of the disk. Its mass regulates how easily gas can escape when feedback pushes upward. Its depth sets the speed needed for a star to depart forever. Its substructure hosts satellites whose slow spirals inward can thicken the disk and heat its stars. Its mild asymmetries can tilt the entire system and warp the outer regions without malice or plan. The unseen is not passive. It is the stage and the scaffolding. He lingers on a final image, a snow globe without glass, filled with warm breath of coronal air, with faint elder stars tracing ellipses so slow that lifetimes pass without noticeable change. At the centre, a glowing disc spins like a music box that winds itself. The melody is audible only when one listens through instruments tuned to gravity and to the shy colours of excited ions. The halo is the auditorium. The applause is silence that refuses to empty. The night contains waters that do not wet the hand. He lifts his gaze above the luminous disk and finds currents made of atoms, streams that wind across hundreds of thousands of light years, faint as breath on glass, yet persistent as a tide. A ribbon sways across the southern sky, stretched behind two companion dwarfs that circle like shy fish near a leviathan. This band contains hydrogen so thin that a cubic centimetre would hold fewer particles than a cathedral holds worshippers, but it sprawls with a confidence that mocks its poverty. The Magellanic Stream drapes the halo like a river pulled from its bed and set to wander across open air. Where a river runs, questions gather along the banks. The first is origin. Do the twin dwarfs shed their gas through mutual wrestling, tearing at each other until a shared tale unspooled? Did the great spiral siphon the material with a patient tug that never looks dramatic in any single year, yet steals oceans in a billion? Or does some invisible wind, hot and diffuse, comb the dwarfs as they fall inward, stripping gas the way high-altitude airstrips paint from the nose of a fast plane? The sky contains evidence for each method. Tidal forces leave stars and gas entangled. Ram pressure prefers to comb gas alone. The observed stream shows long folds that suit both tails. The current does not vote. It flows. The second question is fate. The river's clouds should evaporate under the caress of hot halo gas. Kelvin and Helmholtz named the instabilities that nibble at every boundary where a fast flow shears past a slow one. The numbers predict a swift death for such droplets. Yet the stream persists, a lace of clumps and filaments that survive the trip. Survival implies protection. Magnetic fields may lend cohesion, threading the clouds with lines that resist shredding. Cooling may outrun mixing in places, allowing the gas to condense faster than it can disperse. Perhaps the river is constantly renewed, replenished from its source like a fountain whose falling water hides the fact that individual drops do not return. He turns to the chemistry, because water in a real river remembers the rocks it has touched. The atoms in this celestial current carry the same habit. Neon and oxygen ratios hint at the degree of prior star-making. In some regions, the gas seems modestly enriched, a signature compatible with the dwarfs that trail ahead. In other knots, the metallicity looks lower than expected, as if parts of the stream gathered from a more pristine reservoir. The mosaic suggests a braid. Some strands come from the companions. Some may condense from the halo itself. Some may have been lifted from the outskirts of the main disk during a past encounter. A single ribbon hides several threads. A different flow heads the other way. Gas also rises from the starry city. Supernovae deposit energy into surrounding clouds and loft material into the heights, where pressure and buoyancy conspire to carry it outward. Feedback creates chimneys and fountains. Some of the lofted matter cools and rains back, closing a local circuit. Some reaches the larger reservoir and thickens the halo. Rivers that descend and rivers that ascend meet without ceremony, exchanging heat and metals in a dialogue measured in recombination lines and faint X-rays. Every exchange changes the odds for future star birth. Every change redraws a boundary of influence that no cartographer can ink in a single stroke. Below these grand features, smaller tributaries move with quieter drama. High-velocity clouds glide with speeds that deny simple membership in the disk. Some may be fragments of the broader rivers. Some may be gas-rich dwarfs in disguise. Some may be condensations from the hot medium that have won a temporary reprieve from evaporation. Their distances range from near to far. Their densities vary by factors that challenge any easy generalization. Each one is an instrument in a symphony where percussion is played by shocks and woodwinds by cooling flows. Together they thicken the feeling that a galaxy lives at the nexus of weather. The picture complicates again when he imagines time as a camera with a long exposure. Rivers move, but they also write history in the landscape they cross. The sky's rivers feed disks and star clusters for generations. Their courses change, not in response to a single storm, but as the orbits of their sources precess slowly under gravity. A bend seen today may be straight in a few 100 million years. A gap may close. A new branch may sprout, where a dwarf arrives with a fresh gift of gas. The perimeter of influence grows and shrinks with these additions, never still, never finally sharp. The temperature of the water matters. Cool gas can seed future stars. Warm ionized gas glows in lines that reveal densities and paths. Hot gas acts as a solvent that dissolves cool clumps unless cooling can outrun conduction. Measurements distribute the material across these phases in ratios that depend on radius and direction. In one quadrant, the cool fraction fattens, as if shade protects it. In another, the warm dominates, like fog under a pale Sunday. Anisotropy becomes as important as abundance. The galaxy does not sip evenly from its surroundings. It drinks through straws placed by structure. He revisits the companions that haul the most obvious stream. The larger of the pair contains a bar and bursts of youthful light. The smaller looks ragged, bruised by past tangles. Their orbit carries them through the outskirts like two leaves caught on the same eddy. The timing of their approach matters. If they were captured recently, the stream records a first meeting between river and basin. If they have long been bound, the record becomes a palimpsest of previous passages overwritten by new ink. Each possibility redraws the chronology of a galaxy's diet and exercise. Close to the plane, another cloud looms with its own puzzle. It rushes toward the disk with energy enough to bruise. Its origin offers a handful of hypotheses. It may be a returning fountain droplet grown massive with borrowed air. It may be a remnant of a dwarf that shed its stars long ago but kept its breath. It may be a splinter of a larger filament caught in a local current. Astronomers model the expected impact where it meets the disk and watch for the telltale signature of compressed gas and newborn stars. The boundary between city and sky behaves like the interface between river and delta, rich in opportunity, sensitive to angle and speed. Gravity never yields the stage, even when gas seems to be the main actor. The rivers trace potential wells that owe their depth to dark matter as much as to starlight. Subhalos within the larger well stir the flows with small, persistent hands. A passing mass can kink a stream or break a filament into beads. The beads merge or evaporate according to conditions that change with altitude. The behavior turns simple shapes into calligraphy that requires patience to read. The writing includes commas and question marks in equal measure. Instruments reveal the ink through different tricks. Radio telescopes map neutral hydrogen by its quiet line at 21 centimeters. Ultraviolet spectrographs capture the fingerprints of ionized oxygen and silicon when a bright beacon shines behind the river. X-ray detectors pick out the faint heat of a shocked interface. Each method points to the same truth. There is more material between galaxies than casual sight admits, and it moves with intention supplied by gravity and feedback. The notion of a tidy edge fails under this testimony. What looks like a perimeter becomes a mixing zone, both porous and structured. A river needs a basin. The basin in this case is the halo, a weakly defined volume whose character changes with distance from the center. Near the core, the flows have short cycles. Far out, they stretch into arcs that take aeons to complete. The basin tilts slightly, warps gently, and hosts eddies that trap gas for long spans before releasing it. None of this requires a mind. All of it produces behavior that rewards careful attention. The city's future depends on these distant phenomena. A drought in the rivers would starve the disk of raw material. A flood would overwhelm delicate balances and quench star formation by heating rather than feeding. He closes his eyes and imagines sound attached to these processes. The radio line becomes a deep hum. The ultraviolet lines chime like thin glass stirred by a wet finger. The X-rays hiss softly, the white noise of a kettle just before it sings. The chorus rises and falls with time, never in unison, always with some instrument taking the lead while others recede. The melody writes itself into the next generation of stars, into their metallicities, into the thickness of the outer disk, into the random speeds of older populations. The escalation lies in the realization that every answer about these rivers spawns a fresh problem. Proving the source of one arc forces new questions about the timing of capture. Measuring the survival of one cloud demands a better accounting of magnetic support. Estimating the total inflow unveils a mismatch with the rate at which the disk spends its gas, inviting a recheck of hidden reservoirs. The boundary of the galaxy stiffens and softens by turns under these revisions. Each current redraws the coast. Each redraw requires new instruments and new patience. A soft roar rises from the core, a wind that no ear can hear and no sail can catch, yet it writes itself across the sky with an artist's assurance. Above and below the central bulge, paired lobes bloom in hard light, smooth of face and sharp at the rim. They stand like twin lanterns hung on a pole of darkness. Their glow comes from particles that learn to run near the speed of light, then through their energy into photons that carry the story outward. The story is simple to say and difficult to conclude. The galaxy breathes. Gamma rays reveal the larger shapes most starkly. The lobes reach tens of thousands of light years into the halo, almost symmetrical, almost calm. Their edges hold a crispness that hints at shocks or contact surfaces where a hot interior presses against a cooler surround. Within the glow, turbulence whispers rather than shouts. The wind appears disciplined. A memory of collimation lingers, as if the outflow set out through a funnel and only later relaxed into rounded volumes. The picture suggests a central engine that produced a powerful exhaust and then stood down. Another light tells a related tale. In soft X-rays, broader bubbles spread beyond the gamma structure, like pale halos around brighter cores. The contrast between the two layers hints at stages. A hotter, older push may have inflated the larger cavities. A more recent or differently energized episode could have lit the inner lobes in gamma. The wind may not be a single breath, it may be a cadence. Outbursts with different temperatures and particle populations overwrite one another without erasing the underlying map. The question of origin sits at the center like a coiled spring. Two plausible culprits share the stage. One is a quickened heart of star formation near the nucleus, where clusters of massive stars live and die in compressed neighborhoods. Supernovae, arranged in waves by clustered births, pump energy into surrounding gas, and can drive a collective outflow that punches through the crowded lanes. The other is the black hole at the core, a quiet neighbor most days, but capable of brief awakenings when a parcel of gas surrenders angular momentum and dives inward. Even modest feeding episodes can produce jets, winds, and radiation strong enough to excavate cavities and fill them with cosmic rays. Clues litter the fields above the plane. Filamentary radio features stretch in long strokes, sometimes aligned with the symmetry axis of the lobes, sometimes canted, always suggestive of magnetic order. The fields thread the hot gas and guide the motion of swift electrons that shout in radio frequencies as they spiral. In X-rays, narrow chimneys rise from the crowded central molecular zone, as if the outflow had etched channels through which heat and plasma climb. Closer to the midplane, line emission from warm gas displays a modest cone that points the same way. Multiple messengers trace the same gesture. The center speaks in beams. Age estimates recite a range, but converge on a feeling. The wind is young in cosmic terms, older than human history by a factor beyond reckoning, yet not ancient by galactic standards. Tens of millions of years would smear the edges to indecision. Thousands would not inflate such distances. A few million to a few tens of millions seems to fit. If energy arrived impulsively, a brief flash might have set the shape and then faded to a residual hum. If energy arrived in a series of bursts, each burst could have refreshed the form without always sharpening it. The wind may have a duty cycle, a schedule made by gravity, chance, and the habits of gas in a crowded core. Dynamics supply a stern constraint. The pressure inside the lobes must balance the weight of gas and the inward push of surrounding thermal plasma. That pressure can come from a mix of sources. Hot thermal gas does part of the work. Relativistic particles carry another portion. Magnetic fields add stiffness. Their sum sets the expansion, the speed of any shock, and the drift of the edges. Each contribution leaves a fingerprint in the details of the spectrum. None expresses itself alone. The wind is an economy that draws from several accounts. The path from core to halo also changes the cargo. As the outflow rises, cool clouds within reach can be plucked and carried as passengers. Some survive the trip to high altitude, shedding mass as they go. Some are shredded into drips and then vapor. Mass loading alters the temperature, and the momentum budget turns a fast beam into a heavier, slower gust. Internal shocks bloom where faster parcels overtake slower ones. Compression brightens filaments. Reconnection along tangled magnetic lines releases pockets of energy that freshen the radiance in microwaves and gamma rays. The wind is not clean. It is fruitful. Chemistry remembers these journeys. Spectral lines from oxygen and neon in ionization states that prefer high heat tell of gas that has been cooked and stirred. The ratios of elements betray the contribution of massive star deaths and of longer-lived progenitors. If the wind arises mostly from black hole duty, the enrichment pattern tilts toward whatever the core had on the menu when the meal began. If the wind bears the work of starbursts, the pattern shows the blended ash of many supernovae. In either case, the halo receives more than heat and momentum. It receives metals. The outskirts grow older by taste. Geometry answers a few questions and asks more. The lobes align roughly with the minor axis of the galaxy. This is expected if vertical pressure gradients offer the least resistance. The cross-section shows limbs that bow in slightly, as if surface tension held an invisible skin taut. Some images reveal inner spurs, as if the breath within the bubbles has its own storms. The overall symmetry looks admirable, but small fractures and asymmetries suggest a real history that includes bumps and drafts. No laboratory wind tunnel can match the scale or the patience required. Only the sky can run the experiment. Consequences ripple back to the city of stars. An energetic core regulates the availability of cold gas in its neighborhood. Too much heat and the clouds cannot settle. Too little and the region sinks into a torpor that fails to reprocess old material into new youth. The wind participates in this balance. It removes some gas and returns some after cooling. It sculpts the density field and seeds vortices where condensation can begin. It throws a soft net of pressure over the inner few thousand light years and over the first tier of the halo, forcing both to consider new equilibria. The wind also speaks to escape. The speed required to quit the galaxy depends on radius and direction. Movement along the axis of the wind can ride a changing pressure gradient. Cosmic rays that stream outward may drag magnetic fields along, opening channels. Hot ions flow across these lanes with different ease than cooler atoms. Neutral clouds feel the ram pressure directly. Ionized plasma follows field lines and pressure gradients. The outflow becomes a set of highways and service roads, each with different speed limits and tolls, each used by a different class of traveler. Time makes an editor of every structure. As the wind ages, its brightest messengers dim. High-energy electrons lose their edge through radiation. Thermal gas cools, first by line emission, later by bremsstrahlung and adiabatic expansion. Once sharp edges blur. The imprint remains in the distribution of temperature and in slight depletions of density that function like footprints. A new episode can step into that space and refresh the trace. What appears constant in a snapshot is often the superposition of several pages laid one atop the other in semi-transparent ink. Speculation leans towards synthesis. A modest feeding event at the black hole could have lit the lobes, while a sustained starburst in the nuclear ring could have provided the longer, broader push seen in softer light. The two engines need not compete. They can collaborate. The black hole is a drummer that sets tempo during brief solos. The clustered supernovae are strings that carry the theme across many measures. The score reads as wind, heat, and particles arranged in a geometry set by the environment and by magnetism. Instruments hone the ear for this music. Gamma-ray telescopes trace the highest energy notes. X-ray eyes watch the heat. Radio arrays follow the braided fields. Spectrographs in the ultraviolet eavesdrop on ions that prefer the in-between temperatures where many exchanges occur. Together they outline a breathing structure that links core to rim. The outline is not perfect, yet it is precise enough to insist that the galaxy spends energy on a vertical conversation. That conversation shapes the outskirts and loops back to the heart. He lingers, picturing the lobes as slow clouds lit from within by lightning that never cracks. The edges are tide lines on a black shore. The interior glows with the afterimage of haste long past. Every particle carries a history of accelerators, shocks, and drifts. Every photon speaks of a collision between speed and light. The wind does not tire. It pauses, then resumes, an organ of regulation that keeps a disk from choking on its own smoke and a halo from starving for attention. Above and below the plane, the airless sky remembers each breath and waits for the next. Gravity writes contracts that few can break, yet the sky holds signatures of those who tried. Far from the crowded lanes of the disk, a handful of stars cut paths that curl toward independence, their speeds high, their fates undecided. They are not rebels in the romantic sense. They are outcomes, precise and cold, born when a system with many bodies rearranges its debts. Some leave quietly after a family quarrel. Others blast away as if shot from a spring wound at the center of the galaxy. Each becomes a tracer of the gate that guards the border. The simplest escape begins with companionship. Two stars in a close orbit carry a hidden violence, the stored energy of a dance that can be interrupted. When one explodes, the partner loses its partner's pull in an instant and continues forward with the speed that once balanced gravity. If the kick from the blast aligns with that motion, the survivor departs with haste. Such runaways can reach hundreds of kilometers per second, enough to cross the disk and rise into the halo, sometimes enough to slip the general pull entirely. Their spectra carry the memory of their birthplaces. Their chemical fingerprints tell of youth interrupted, of heavy elements mixed by a nearby detonation, of a life plan torn and rewritten by pressure and light. A more dramatic expulsion waits near the central black hole. Binaries that wander too close can be torn apart by tidal forces that do not care about vows. One member falls inward, captured by the deep well, while the other is catapulted outward with a gift of speed stolen from the orbit. The Hill's mechanism transforms intimacy into exile. Velocities in excess of 1,000 kilometers per second appear in the arithmetic. Even a massive halo cannot always hold such a traveler. The star becomes a needle of light aimed at the suburbs of the galaxy and beyond, a messenger that will never return to the town that raised it. The shape of the escape code depends on distance from the center. The speed required to be forever free is not constant. Near the core, the demand rises with the stacked mass of bulge and black hole. Farther out, dark matter thickens the air of space in a way the eye cannot see. In the outskirts, where starlight falters, the required speed still sits around several hundred kilometers per second. This curve, the escape velocity as a function of radius, acts like a litmus test of the unseen. A star that crosses a local threshold with room to spare tells how deep the well must be. A star that hovers near the limit sketches the slope of the potential. The rare star that clears every hurdle chisels an arrow on the border that reads open. Between these spectacular cases live many subtler attempts. Clusters pass one another, exchange members, and sometimes sling an unlucky star clear of all gentle options. Spiral arms gather and scatter, stirring orbits so that a portion of the population drifts outward over many cycles. A dwarf galaxy that falls toward the larger system can give a fragment of its speed to a few stars and endow them with trajectories that do not close. The mechanics are indifferent to scale, from a close exchange near a compact remnant to a broadly tuned resonance with the pattern speed of a bar. The result is the same. A handful of bodies find themselves on paths whose far points lie in cold sparsity. He follows one such star in thought, a blue point bright enough to be seen across 100,000 light-years. Its path emerges from the inner few thousand light-years, tilts out of the plane, and then straightens under the influence of the global potential. Along the way, it threads past the remnants of ancient streams, its speed too high to be captured. Gas means nothing to it. Dust cannot slow it. Magnetic fields do not grip its neutral heart. Its story is written in pure inertia and the slow decline of a well it has already paid, almost in full. In a few 100 million years, it will move through a space where the galaxy is a luminous coin behind it and the local group a sparse arrangement ahead. Not all escape artists shine. Planets are ejected from newborn systems in quieter dramas. When giant worlds migrate or when multiple large planets compete for parking space, gravity chooses winners and losers with simple rules and ruthless outcomes. The losers become wanderers, cold and almost invisible, their atmospheres carrying the ancient imprint of the stars that formed them. Some remain bound to the galaxy. A few may acquire enough speed in cluster interactions to leave the overall pull entirely. Each speaks to the variety of ways a boundary admits departures, from explosive to polite. Particles tell a parallel tale. Cosmic rays race outward with near light speed, riding tangled magnetic lines that loop and bow above the disk. Many will mirror and return, their paths stuck within the net of field geometry. Some will diffuse far enough, over long times, to find lanes that do not loop back. Others will follow channels carved by outflows from the central regions and reach distances where the galaxy's influence weakens. Their voyage is not a clean jump. It is a staggered drift, a random walk through a maze whose walls keep moving. Yet the statistics point outward. A fraction gets away. Gas can attempt the crossing in bulk. Superbubbles from clustered supernovae open chimneys through which hot plasma pours into the halo. The flow slows as it meets the weight of the surrounding medium. Some parcels cool and fall. Some entrain cooler clumps and give them a ride to higher altitude than they would have achieved alone. A small fraction, heated enough and light enough, approaches the threshold for escape. The numbers are harsh. Most of the mass returns, in one form or another. The few that do not become part of the galaxy's quiet exchange with the intergalactic medium, a modest leak that still matters over aeons. The scale of these events begs for calibration. Human craft that leave the heliosphere feel heroic in their own story, yet their speed is a whisper compared to the demands of galactic escape. Tens of kilometers per second carry a machine out of the sun's breath. Hundreds carry a star toward freedom. Thousands deliver a verdict that even a massive halo cannot revoke. The comparison is not a slight. It is a reminder of the gradient that separates local triumphs from cosmic arithmetic. It is the arithmetic that marks the border. Evidence for escape does not always announce itself with obvious parabolas on a sky map. Distances, proper motions, and radial velocities must be braided to recover a true path. Instruments that track positions over years add their quiet precision to spectrographs that measure line shifts with the discipline of metronomes. From this braid, three-dimensional speeds emerge. Some of the motley drifters prove less dramatic when distances are corrected. Others grow more astonishing when their parallax settles. A few transform from curiosity into proof, their speeds consistent with a one-way journey past all practical recall. Each confirmed departure is a biopsy of the gravitational body. The number of such stars, their origins, their directions, and their distribution in speed carry information about the mass profile, the presence of perturbing substructures, and the history of central feeding, A burst of ejections can point to a past episode of disruption near the black hole, perhaps a period when binaries fed its tides more frequently. A trickle that arises in a particular quadrant can suggest a long resonance with a bar or a spiral arm that whittles at orbits over many rotations. Outliers in chemistry can tie a runaway to a specific nursery before exile. A pattern emerges from these fragments. Not symmetric, not simple, yet legible. The fate of these emigrants reaches beyond the sentimental. As they travel through the outskirts, they light regions otherwise star-poor. They can ionize thin clouds enough to leave a tracery in faint lines. Their wins and eventual deaths, if they are massive, inject energy into volumes that seldom know such attention. Even a single supernova at great height can knot the local medium into shapes that persist for a long time. In a very quiet neighborhood, a loud neighbor matters. There is a final category of escape that runs in reverse. Objects not born within the galaxy arrive with speeds that ignore local tradition. They carry eccentricities that do not fit any family of orbits. Their composition reveals histories written under suns that lie elsewhere. Their visits are short, their angles odd, their paths a reminder that the border does not only govern exits, it receives entries. Some entries pass through and leave almost immediately. Some find themselves captured into long, looping arcs that keep them as unusual citizens for a while. The border remains honest. It regulates both directions. The idea of escape rounds into a simple picture. A gravitational well is a cup of many materials, deep at the center, shallow at the rim, lined with lumps and threads. To climb its side, an object needs speed, or a series of small gifts of speed, or a partner that trades energy at the right moment. Those who rise far enough find the slope flattening. Those who crest discover that the far side is not a cliff, but a plain. On that plain lies a sparse country where different agreements hold, where the pull of the galaxy becomes one term among several, and where the night has different customs. Two gravities greet each other across a modest gulf and agree on terms that last for billions of years. On one side, a spiral city of stars exerts its pull. On the other, a neighbor of comparable dignity leans in with a matching persuasion. The space between them is not empty. It is a compromise, a low plain, where the slopes of two wells meet and flatten. Far beyond the plain, a quiet drift tugs outward as space itself lengthens. The result is a frontier that is neither wall nor blur, a region where allegiance is measured by the sign of acceleration and by the patience of orbits. He imagines a line connecting the two great members. Along that line lies a saddle, a point where a small body would feel equal claims in opposite directions. Closer to one side, a satellite finds its loyalty clear. Closer to the other, the choice reverses. In 3 dimensions, this balance expands into a surface that folds and bulges like a soft shell pressed between 2 hands. Within the shape, one family holds authority. Outside it, the other does. The shell shifts slowly as mass redistributes, as gas flows, and as tides from the wider group establish their minor edits. The geometry is not metaphor alone. It is mechanics made visible in thought. The nearest large neighbor approaches on a collision path set by the arithmetic of their shared history. Their mutual fall began long ago, when their separation was small in relative terms, and the expansion of space had not yet gained the leverage to keep them apart. That initial approach wrote a promise into their motion. The universe became larger, but the promise remained. The plain between them today is therefore temporary countryside. In the deep future, it will be a street inside a new city. For now, it acts as a qualifying ground, where the pull of one host fades and the reach of the other begins. Satellites supply the evidence needed to draw this moving coast. Dwarf galaxies orbit in pearled strings. Some cling close and circle with periods shorter than a cosmic hour. Others wander farther, tracing loops so wide that a full revolution would outlast the age of complex life on a single planet. The farthest of the claimed kind test the border with every apicenter. Their speeds and positions demand a mass estimate for the host that keeps them. If the estimate proves too small, loyalty would break on the next pass. If too large, dwarfs that ought to be free would appear falsely bound. The right figure delineates a practical domain, the volume within which promises can be kept. Beyond the personal sphere of a single host, the entire congregation of nearby galaxies participates in a second balance. Outside the group's combined reach, galaxies resume their participation in the general recession. Their distances increase according to a quiet rule, and their motions line up along a slope that astronomers graph with satisfaction. Inside the group's envelope, peculiar velocities confuse that slope. Objects fall toward the center of mass and stall against the outward tug of expansion. The surface that divides these two behaviors is the zero-velocity boundary. Inside it, the group is a federation with its own time, resistant to drift. Outside it, the sea of space resumes its tide. The frontier is not only radial, it is also directional. Along the axis that connects the major members, tides stretch and squeeze. Perpendicular to that axis, the field relaxes. A small galaxy that orbits in the equatorial directions will feel a different history than one that happens to ride the Great Line. The distribution of satellites reflects this anisotropy. Alignments in their positions and in their orbital poles suggest that large-scale filaments feed the group along preferred paths. The filaments act as roads that bring in fresh dwarfs and cool gas, but they also impose orientation on the outskirts. The frontier becomes textured, with troughs and ridges set by the large-scale web. At the edge of personal influence, a different radius asserts itself. It is the tidal limit, the distance at which the gradient of the neighbor's gravity equals the binding pull of the host. Beyond that limit, a satellite can be unstitched without entering the other's territory outright. Streams appear that arc away like pale handwriting. Some are pinned to the host by thicker strands. Others sag toward the rival well and begin a slow defection. These quiet betrayals are maps the sky draws for patient readers. Each strand marks where jurisdiction faded and where a new allegiance was suggested by the geometry of mass. Coldness in the local drift furnishes an additional clue. In the outskirts, galaxies just beyond the group's fence follow the general expansion with remarkably small scatter. Their motions around the smooth trend are modest, an indication that nearby mass concentrations are not violent enough to ruffle the flow. A calm sea means the island exerts a controlled pull. The group can be weighed by how far its influence extends before the calm sets in. The resulting number, when compared to the bound mass of the principal members, delivers a useful check on how much unseen matter the group as a whole must carry to maintain its federation. He pictures the barycenter, the point where the group can be balanced on the tip of an ideal needle. It lies closer to the heavier member, offset by the fraction of mass that each contributes. Every satellite orbits this arrangement, not an isolated single body. Even a star at the boundary of a host's halo responds to both pulls and to the group's collective motion. The barycenter migrates slowly as the principal pair approach. That migration translates into gentle tides that visit the outskirts, heating some orbits, cooling others, opening temporary windows where a dwarf can be captured or released with minimal fuss. Gas respects these arrangements with its own flavor of obedience. Clouds that drift near the static plane feel the difference in potential through gradients of pressure and temperature. A stream torn from a companion may stall at the group's midland, then tip toward one side when a change in density or a brush with a subhalo breaks the tie. The highest altitude of cool gas often marks the limit where heating by the group's bath of warm plasma overcomes radiative loss. That limit tends to sit near the edge of personal influence. It is another sign that the frontiers of galaxies are written in phase changes as much as in positions. There is a temporal flavor to the boundaries that matters as much as spatial form. The group did not assemble all at once. Its envelope grew as the major members accreted satellites and as the general expansion slowed relative to local gravity. The zero-velocity surface expanded and then settled. The personal tidal limits swelled as the hosts grew heavy with dark matter and with the remains of digestible dwarfs. Today's coast is the sum of those developments. Tomorrow's coast will be drawn again by the coming embrace of the two giants. The truce is real, but it has an expiration that can be measured on a clock set for a few billion years. The frontier breeds rare citizens whose orbits graze contradictory loyalties. Some dwarfs trace long ovals that carry them far from a host and then back, each apocenter testing whether the group prefers to reclaim them. Some barely belong, drifting in gentle resonance with the combined field. A few may be true interlopers, visitors from neighbouring associations whose paths have been bent into momentary companionship. Their chemistry reveals stories written under other suns. Their velocities read like passports stamped in multiple ports. Such cases keep the frontier honest by forcing definitions to admit exceptions. Instruments trained on this region practice a kind of diplomacy. They measure distances with exquisite care to distinguish the bound from the drifting. They tie velocities in three components to positions and uncover the tug of hidden mass. They map the feathery remains of shredded satellites and place those features in context with the larger geometry. The consistent picture is not austere, it is rich, a playground of negative and positive energy orbits, of turnarounds and soft captures, of gradients that sculpt outcomes without raising their voices. He lets the scene assemble in a single frame. A pair of large spirals approach, with the quiet of two planets far from a star, their pace set by a shared private gravity. Around each, flocks of dwarfs flutter like birds that understand a coastline by heart. Between them lies a plain where the pull of either can be resisted under the right conditions. Beyond the whole assembly, the sea of general expansion resumes and carries remote islands away. The frontier appears as a living compromise, not a line scratched by decree. It is a field where claims are negotiated by mass, distance, and time, and where the outcome can be read in the way small bodies choose their long loyalties. He looks outward until gravity becomes a texture, rather than a single pull. The night, so often imagined as empty, reveals a faint skein that binds what appears separate. Across distances that make cities and clusters alike seem small, the universe arranges itself into threads, sheets, and knots. The knots glow as clusters. The sheets stretch like veils with faint embroidery. The threads link these forms in filaments that carry matter as rivers carry silt. What the eye cannot see, patterns of motion declare. Dark matter lays the scaffolding. It neither shines nor resists passage by absorbing light. It settles into a cosmic lattice sculpted from the ascent of early fluctuations. Gravity gathers it along converging flows, and with time those flows sharpen into chords. Gas follows, dragged by the same wells and slowed by pressure and cooling. Stars ignite where the gas piles up or where shocks press the matter to higher density. The result is a web, not of silk but of potential, with the visible universe caught like dew. He studies a single filament in thought. It is not a perfect cylinder. It swells near a cluster, narrows between knots, and frays into tributaries near the outskirts of a group. Its core holds warm gas that spends its heat in quiet radiation, and hotter gas that whispers in X-rays too faint for easy detection. Along its spine run small galaxies and the debris of forgotten dwarfs, each one a bead moving with the slow insistence of a clock wound by the mass of the entire structure. Magnetic fields thread the gas and guide charged particles in gentle spirals. The field lines bend with the flow and tangle where turbulence sharpens, adding stiffness to a medium that would otherwise yield too easily. At these scales, the census of ordinary matter acquires a patient tone. A significant fraction resides between galaxies, in a phase that resists direct sight. Some is ionized and almost transparent, its atoms stripped of electrons by background light and past shocks. Some is warm and tenuous, its brightness dependent on long exposures against an indifferent sky. To find it, astronomers use distant beacons. A quasar shines like a lighthouse set beyond the coastline. Its spectrum carries the shadows of intervening gas as narrow bites at specific wavelengths. Each bite marks a cloud or a sheet along the line of sight. Together they write a ledger of the thin world between the bright islands. The same beacons reveal the presence of filaments by the way they distort and redden light. Gravity itself bends the path, acting as a lens that magnifies and shears faint galaxies behind the web. The distortions are subtle. Gather enough of them across a wide field, and a map emerges, not of stars but of mass. The filaments appear as bridges between heavy nodes. They are not artistic flourishes. They are load-bearing spans, carrying a traffic of matter that shapes the fate of every city attached to them. Closer to home, the web becomes personal. The region of space inhabited by the nearby galaxies lies within a gentle sheet, a flattened association whose members share a preferred plane. Perpendicular to that plane opens a quieter direction, a local void that contributes an outward push by being less dense than average. Motions within this environment trace paths set by both presence and absence. A galaxy moves not only toward the filled knots but also away from the emptier reaches. The velocity field reads like wind around hills. It can be measured by comparing estimated distances to observed redshifts and by subtracting the universal expansion. The patterns that remain are the currents of the web. A filament does more than convey mass. It offers an orientation to those who grow upon it. The spin axes of disk galaxies often align modestly with the direction of the nearest thread, either parallel or perpendicular depending on history and mass. Alignments extend to the orbits of satellites, which gather along preferred approaches that map the larger roads. These preferences are not strict laws. They are habits written into the initial conditions and reinforced by subsequent flows. The outskirts recall them in the disposition of star streams and gas plumes that fall in along these paths. The transport of gas along filaments carries a consequence for star formation. At epochs when the universe was younger and denser, cool streams could reach deep into the halos of modest-mass galaxies without first being heated to the virial temperature. Such direct feeds deliver fuel at a pace that sustains high birth rates. At later times and in more massive systems, shock heating at the halo boundary tends to warm the gas into a state that cools more slowly. The filament then becomes not a rush of cold water entering the city, but a wide aqueduct whose contents must settle and shed heat before they can join the inner reservoirs. Even in that slower regime, the filament keeps the supply line open. Quiet replenishment sustains a temperate disk. He imagines the meeting point where a filament kisses the edge of a halo. The gas decelerates as the gravitational gradient steepens. Weak shocks form where streams converge or where the hot coronal medium pushes back. Pressure rises. The path bends under the influence of the local shape of the potential. Regions of compression ripple along the contact. In those regions, cool clumps can condense from gas that has radiated away enough heat. These clumps sink slowly toward the disk, tilted and twisted by the small currents they ride. Their metallicity reveals the recipe of the larger reservoir, enriched by star death but still modest compared to the crowded lanes of the city below. The web not only feeds, it also sips the byproducts of activity. Outflows from clusters of supernovae and from central engines vent plasma and cosmic rays into the surroundings. Filaments receive a portion of this material. Metals diffuse into the spine of the thread, changing the cooling properties of the gas far beyond the bright disk. Over time, this exchange blurs the distinction between what belongs to a galaxy and what belongs to the road that serves it. The frontier is redrawn as a zone of sharing, with balances that change as tides and traffic vary. Heat moves along these paths as well. Inverse Compton scattering imprints a faint signature on the glow of the cosmic microwave background, where hot electrons in filamentary gas boost photon energies. The effect is delicate yet cumulative. Over large areas, it hints at a web laced with warm bridges between clusters. Where those bridges cross a line of sight to a background source, their presence is betrayed. The detection is not theatrical, but it strengthens the feeling that space between the bright nodes is not a mere gap. It is a corridor with pressure, temperature, and a history of shocks. The geometry of the web governs the drama of mergers. Galaxies that share a filament are more likely to meet. Their relative velocities are set in part by the slope of the potential along the road they share. Major collisions tend to happen near the nodes where routes converge, while the edges of filaments host slower, quieter accretion. The outskirts of a galaxy near such an edge experience a long season of mild influence, punctuated by rare arrivals whose origins can be traced upstream. The pattern is not random, it is path-dependent, a memory of the roads taken by matter since the early days. He attends to the silence of the voids that open between filaments. These are not absolute emptiness, but they are underdense by comparison. Their expansion exceeds the cosmic average, creating a relative wind that pushes on nearby structures. The boundary of a galaxy that sits near such a cavity will feel a slight tilt in its outer orbits and a gentle asymmetry in gas distribution. Streams that approach from the void side will be rarer and more tenuous than those that arrive along a filament. The resulting anisotropy writes itself into the morphology of the halo and into the locations of high-velocity clouds that serve as local scouts. Satellites are among the most telling pieces in this extended game. Many appear not as isolated arrivals, but as members of faint trains aligned with the nearest filament. Their orbits reflect the approach direction and preserve the memory even after many cycles. When they are torn into streams, the shards trace great circles that are not randomly placed. The placement often parallels the large-scale road. This match between small structure and grand avenue persuades the mind that borders are braided into the larger landscape. Instruments give the web a measurable pulse. Large surveys build three-dimensional atlases of galaxies with redshift as the depth coordinate. Weak lensing maps lay a gauze of mass atop those distributions. Radio arrays tune to the quiet line of neutral hydrogen and seek it in the sparse country between the knots. Ultraviolet spectrographs wait for a quasar to land behind a suspected thread and then read the absorption ledger. Each technique needs patience and scale. Each returns with a slice of the same theme. The sky prefers continuity over isolation. He lets the vision resolve. A single galaxy sits at the edge of a cord that runs to a wider junction. Gas drifts along the cord, hot in places, cool in pockets, stirred by the feedback from the city and from its neighbours. Dark matter supplies the form. The galaxy's halo kisses the filament at a boundary that is neither flat nor final. Orbits tilt toward the road. Streams unspool along the same direction. Outflows lift and richen the nearest span. There is no arrogance in this arrangement. There is only membership, a belonging that admits exchange. In such a setting, a boundary is not a finish. It is a weave, the last visible threads of a fabric that continues past the reach of starlight. The city ends, the avenues begin. The hand that maps them does not need to trace infinity. It needs to show how the bridges cross the gulf, and how the gulf carries its own, almost imperceptible breath. The threads keep their quiet, but they carry the weight of structure with a grace that rewards those who listen for the hum beneath the stars. Edges tempt the cartographer, yet nature answers with a choir of radii that seldom sing the same note. Each one is a measure of belonging, tuned to a different instrument. Together they sketch a coastline in charcoal rather than ink, a dark shoreline where definitions advance and retreat with context, method, and time. He begins with the virial idea, a balance between motion and mass that declares a region to be dynamically relaxed. Inside this volume, random and orbital energies average against gravity in a way that admits a characteristic radius. The calculators prefer a shorthand. Choose a density threshold relative to a cosmic benchmark, often 200 times the critical or the mean density, integrate inward until the enclosed mass satisfies the rule, and name the resulting size R200 or RIA. This radius encloses a halo that acts as a self-respecting city, where statistics of motion hold steady, and the accounting of mass closes cleanly. It is tidy, persuasive, and entirely a convention. Change the benchmark from critical to mean, and the edge shifts by tens of %. Alter the threshold, and the map moves again. Even so, the virial prescription gives a graspable shell that captures much of the weight and most of the gas that believes itself resident. A different line respects tides. No city stands alone in a flat plain. Neighbours raise gradients that pull more strongly on the outskirts than on the core. There is a distance at which the host's cohesion equals the stretching hand of the outside field. Classical texts call it a tidal or Jacobi radius, close cousins to the Hill sphere used for planets around stars. Within that limit, bound orbits survive without constant rescue. Beyond it, loyalty becomes fragile. The value depends on the mass ratio to the nearest heavy neighbour and on separation, so it breathes with the dance of large companions. As two giants draw near, the tidal border contracts. In quieter epochs, it relaxes, allowing satellites to roam a little farther while still signing the registry of membership. Where infall flows shape the outskirts, a sharper landmark appears. The splashback radius marks the first apocentre of recently accreted material, the place where incoming matter turns around after plunging through the centre once and climbs back to its far point. In a spherical ideal, this apocentre produces a steepening in the density profile, a caustic written in radius rather than light. Observers seek the feature by stacking many halos, or by tracing the population of galaxies that have tasted their host and now retreat along elongated orbits. The distance lands near or beyond the virial estimate, with dependence on how fast a halo has been growing. In times of heavy accretion, the splashback sits closer in. In leaner times, it stands farther out, like a tide line shifting with the season of supply. Stars themselves suggest a quieter edge, a change in slope where the density of the stellar halo breaks from one power law to another. This break radius does not mean the mass ends. It records a transition in the origin of the debris that litters the outskirts. Inside the break, relics of larger mergers dominate. Outside, strands from small, long-period accretions hang more lightly. Streams cross this region and remind the mind that the luminous boundary is more a narrative device than a legal fence, yet the break has use. It is a visible cue that the manner of assembly changes with radius, and therefore that a single outline cannot carry the whole story. Gas draws another contour. Neutral hydrogen declines with distance until column densities fall below a threshold where ionization by background radiation wins. Radio maps draw an HI radius defined not by gravity but by chemistry and exposure. Ultraviolet tracers add shells of ionized gas that extend far beyond the neutral limit, a circumgalactic reservoir that blurs into intergalactic flavor with no simple line between. If one insists on an edge, one must choose a phase and an instrument, then accept the bias that follows. The city's breath does not respect a single yardstick. Dynamics propose still more measures. The escape velocity profile, a function of radius, invites a practical definition, where the local speed required to leave equals the typical speeds available to stars and clouds. One can speak of a permeability that approaches open. The radius where few bound orbits remain for a given energy becomes a pragmatic frontier. Likewise, the apocenters of the fastest satellites outline a lived boundary, the farthest points reached by residents who still return. That envelope is lumpy and anisotropic, because accretion prefers directions and dark substructure tugs more here than there. Edges drawn from lived experience never form perfect circles. The environment adds two final borders that ignore parochial hopes. One is the turnaround surface that encircles an entire association, the zero velocity boundary, where Hubble's outward drift pauses against the group's combined mass. It is a fence for the congregation rather than for a single member, and it sits at scales that reduce an individual halo to a parish inside a diocese. The other is the local tidal field generated by the nearest heavyweight. In a pairing of equals, the mid-plane between them hosts a saddle where a free particle would hesitate. Surfaces of equal gravitational potential fold through that region like soft fabric. The location and shape of the folds adjust slowly as the pair approach, and the personal borders of each participant deform accordingly. An honest map must admit that these radii are cousins, not twins. Revere encloses a statistical equilibrium. The tidal limit answers to neighbors. Splashback records history in motion. Stellar break radii speak for luminous debris. HI truncation notes where photons win their slow argument. Escape contours reveal the slope of the well. Turnaround fences the group. None refutes the others. Each asks a different question and returns a different answer. To demand that they agree is to insist that a coastline look the same to a sailor, a geologist, a painter, and a pilot. Evidence grants and withholds in turn. Satellite kinematics weigh the potential and favour a generous virial size. Weak lensing confirms a slow, persistent decline of mass beyond any neat line. Counts of distant background sources seen through the outskirts pick up absorption that refuses to stop at the nominal boundary. Stacked profiles of many halos reveal the expected splashback feature as a bend in gradients that would otherwise relax too gently. Radial trends in stellar populations show a break that folds in the stories of shredded companions. Every method locates an edge, yet the edges form a family portrait rather than a single passport photo. Anisotropy complicates any hope of a perfect circle on the sky. Halos that grew along filaments elongate. Accretion flows prefer those directions, and so do outflows when pressure seeks the easiest escape. A virial sphere drawn in textbooks turns into a triaxial bowl in the living universe, with a splashback shell that is closer along some angles and farther along others. Tidal limits compress toward a strong neighbour and relax toward quieter quadrants. Gas phases pick sides as well, clumping more willingly along roads that feed the city. The best one can do is average over directions or embrace the asymmetry as the real shape of home. Time edits every boundary. The virial radius swells as mass accumulates, and as the background density falls with expansion. The tidal limit shrinks when a neighbour approaches and rebounds after a pass. Splashback migrates as the rate of new infall waxes and wanes. The stellar break creeps outward as fresh streams arrive and settle. The HI contour breathes with the varying strength of the radiation field, and with episodes of heating or cooling. A snapshot is a truth for that instant. A film would tell a different story, in which the shoreline walks back and forth under a sky whose tides run on billion-year cycles. The mind can grow weary of these qualifications, yet their presence is a kindness, because they prevent a false simplicity from hardening into dogma. A boundary in such a system is a set of linked thresholds. Inside one, orbits are mostly closed. Inside another, infall is mostly complete. Inside a third, gas is mostly neutral. Inside a fourth, stars are mostly plentiful. Outside them, different statements become more true. The coast is a gradient made of gradients. He sets down a final, composite image. A dim sphere of influence encloses most of the mass when drawn to a conventional overdensity. Around it, a shell marks where newly captured matter turns for the first time. Beyond that, the group's broader fence holds everything reluctant to join the outward drift. Through and around these shapes run tides from neighbours and filaments from the web, squeezing here, feeding there, pinching at one pole, relaxing at another. The dark shoreline is real, in the way a weather front is real. One can stand in it, feel the change of air, map it with care, and still watch it move. Theories gather at the outskirts like surveyors at a fog-bound shore, each one holding a different instrument, each one swearing that the line will appear if the method is kept long enough. Some carry gravity as scripture, some carry heat and cooling as liturgy, some arrive with radiation as law. Together they attempt to define how a galaxy grows an edge that resists the hand and yet changes its mind with the weather. One family begins with accretion, the slow rain of matter from the large-scale web. In modest halos, streams of relatively cool gas can slip past the outer shock and reach deep into the potential well before being heated. These threads feed the disk with a steady pulse, like aqueducts that carry mountain water to a thirsty plain. In more massive halos, the same inflow meets a barrier. A quasi-stationary shock forms near the radius, where infall kinetic energy balances the pressure of the enclosed atmosphere. Gas crossing that shock becomes hot and buoyant, settling only after losing heat through radiation. The border becomes a thermal front that promotes patience. The edge is where the gas first stalls, and the interior only fills when entropy is paid down. Another family elevates feedback to the status of architect. Stars explode in clusters and carve bubbles that rise, merge, and vent. Outflows thicken the circumgalactic medium, elevating its temperature and stirring turbulence that keeps cool clouds from forming. Some of the lofted matter cools and returns in a fountain. Some mixes with the hot reservoir and lengthens the cooling time. If the flow from the core includes a contribution from a black hole that is briefly well fed, the outskirts receive extra pressure and cosmic rays along with heat. In this view, the edge is a movable firewall, maintained by a budget of energy injections that must, on average, match the radiative losses of the halo. If the ledger overspends on heat, the border swells and the disk starves. If the ledger underspends, condensation proceeds and the boundary retreats toward the center as clouds drop inward. A third family invokes instability as the cartographer. Hot atmospheres that hang above the disk can hover near hydrostatic balance, yet still sit close to a threshold where cooling times compare to the time it takes to fall. Where the ratio dips below a modest value, perturbations in density grow into rain. Multiphase filaments precipitate from the halo and slide inward along paths set by gravity and by magnetic scaffolding. The edge in this story is not a single radius. It is a weather band that circles the system, made of pockets where precipitation is favored and pockets where heat or turbulence suppresses it. The band migrates with changes in metal abundance, pressure, and input from supernovae and from the central engine. The border is a climate zone, not a fence. Reionization steps into the theory as an ancient legislator. When the first generations of stars and black holes bathed the cosmos in ultraviolet light, their photons stripped electrons from diffuse hydrogen and raised the temperature of intergalactic gas. Small halos that had not yet gathered deep wells found their reservoirs evaporated or prevented from condensing at all. A filtering scale arose, a characteristic mass below which accretion of cool gas was throttled. The edges of low-mass galaxies hardened early, not because their gravity set a generous border, but because the background radiation pruned their options. In later ages, even after the global furnace dimmed, the memory persisted. Dwarfs could be quenched at the outskirts by a sky that stayed faintly hot. Environment provides a chorus of secondary effects that act like coastal weather. Ram pressure stripping removes gas from satellites that plunge through the hot medium of a host. Tidal stirring puffs up their stars and loosens their binding near pericenter. Strangulation cuts off the supply of fresh inflow by severing the link to the web once a small halo is captured. Each process produces a shadow in the demographics of the outskirts, a population of dwarfs that arrive with gas and then cross an invisible isotherm where their reservoirs are peeled away. The border becomes a gauntlet through which only the most tightly held breath survives. Other theorists recruit magnetic fields, cosmic rays, and conduction to do quiet work at the rim. Fields add stiffness to the plasma and inhibit mixing between hot and cold phases by aligning charged particle paths along curved lines. Cosmic rays supply an extra pressure component that can lift material without heating it to the same temperatures, thereby changing where condensation will restart on the return trip. Thermal conduction acts like a smoothing hand, erasing sharp gradients, but also delivering heat to cool knots that would otherwise survive. The balance among these processes determines whether clouds shred before reaching the disk or grow by accreting a sheath of warm gas from their surroundings. The edge in this portrait resembles a busy estuary, where fresh water and salt water interpenetrate under the guidance of hidden currents. Angular momentum is assigned a separate desk, and from it comes a shape that theory cannot escape. Material that falls in arrives with spin that reflects the torques it suffered in the web. The distribution of that spin with radius sets how far inward gas can settle before it is supported by rotation. If the outer supply has high specific angular momentum, it spreads thinly and builds an extended neutral layer that reaches into the deep twilight of the halo before turning. If the supply has lower spin, it settles closer to the core and leaves the outskirts warmer and more rarefied. Edges in this view are contour lines of angular momentum, warped by mergers and shifted by flybys, always reactive to the road by which matter arrived. Merger history adds a grammar of interruptions. A single major collision can puff the atmosphere, raise the entropy floor, and move the thermal front outward. Minor accretions deposit long tails of stars and packs of dark satellites that ruffle the hot medium and pinch it into overdensities where cooling can slip through. Each event leaves a punctuation mark. Commas take the form of shells. Semicolons appear as bends in the temperature profile. Periods arrive as transient shocks that carve arcs in X-rays and then fade. The outer script is a palimpsest, written by events that the inner city only vaguely remembers. Alternative gravity receives occasional invitations to the Shoreline Council. Some frameworks attempt to reproduce flat rotation without unseen mass by modifying the relation between acceleration and force at low field strengths. These models often struggle with the full range of halo phenomena, yet they remind the conversation that edges are sensitive to the assumed law as much as to the input data. In any formulation, the outskirts test how the rule applies where the pull is weakest. The cleanest discriminants come from combinations of motions, lensing, and gas temperatures, because no single messenger can adjudicate alone. On scales that fit the entire association rather than a single city, models explore how group tides sculpt the rim. A pair of giants approaching on near radial orbits will pull the outer shells of each other into elongated bowls. The splashback surface shrinks along the line of centers and relaxes elsewhere. Filaments that feed the pair reorient gradually, steering streams into the deepening channel between them. The theoretical edge is dynamic, a shape that tracks not only mass growth but also the choreography of partners. Simulations give these ideas bodies. Numerical universes evolve from early seeds and produce halos that breathe, heat, and rain. When stellar feedback is weak, disks grow too fast and too early, and the outskirts are too clear of substance. When feedback is strong enough to match star formation histories, halos carry multiphase media that agree with observed columns and temperatures, and their borders ebb and flow with plausible vigor. When black hole energy is included with even a modest duty cycle, the largest systems quench their cores while maintaining soft winds that keep the periphery stirred. No single dial controls the coast. A panel of settings produces behavior that looks like weather, with recurring patterns and local surprises. Each of these theories treats the edge as a threshold in behavior rather than a wall in matter. In one, it is where infalling gas shocks and pauses. In another, where outflowing material lifts and then returns. In a third, where cooling times cross a simple ratio and precipitation begins. In a fourth, where radiation prevents small wells from ever filling. In the rest, the boundary is where environment writes its changes and where microphysics decides whether a droplet lives or dies. They are not mutually exclusive. They operate in layers that overlap. The square of the map is a superposition of fronts. A composite forecast takes shape. The outer atmospheres of galaxies are held by dark gravity and heated by a mix of shocks, stars, and black holes. They cool in patches whose fate depends on pressure, metals, and the company of fields and rays. They receive streams from the web that are thicker or thinner depending on mass and era. They return borrowed matter to the disk through fountains whose cadence is set by clusters of supernovae. They lose a share to space through slow leakage along paths of least resistance. The edge lives at the intersection of these motions, an isotherm here, an isentropic contour there, a density break beyond, a kinematic threshold farther out. It is a coast that redraws itself with each incoming tide and each outgoing breath. Instruments gather at the outskirts with a patience that matches the scale they study. The map they attempt cannot be drawn by a single hand. It requires light bent, light absorbed, light scattered, and light delayed. It calls for clocks in motion, needles of radiation set far beyond the rim, and sensors that weigh what they cannot see. The result is a toolkit assembled across decades, a cabinet where each instrument carries a story of careful design and a talent for listening to faint signatures. Background beacons serve as first tools. Quasars stand behind the halo like lanterns hung on a distant pier. Their spectra arrive streaked with narrow bites where atoms in the intervening gas have absorbed specific colours. Oxygen in high ionization states marks hot and dilute regions. Silicon and carbon in multiple stages of charge trace cooler layers that lie near the path from warm to cold. Hydrogen speaks at a wavelength that moves into the ultraviolet for nearby structures, a whisper that can be isolated by spectrographs tuned to clean windows in the sky. Each absorption line is a tally mark on an invisible ledger. With enough sightlines, the tally grows into a map of where the gas thickens, where it thins, where it warms, and where it cools. Closer beacons fill in blanks. Star clusters and halo stars place their light just inside the periphery. Their spectra provide velocities and chemical fingerprints that reveal streams and shells. With sensitive detectors, even the dimmest members surrender proper motions across years. The slow crawl of positions on the sky becomes a choreography. Orbits emerge when distances and radial speeds are folded in. The combined motion writes the slope of the gravitational well and exposes lumps where subhalos tug. Star by star, the outer structure becomes a pattern rather than a rumour. Radio arrays grant the outskirts a voice at 21 centimetres where neutral hydrogen emits a quiet line. The line is delicate, but large dishes and phased fields of smaller antennas weave signals into wide maps. Where the gas is truly neutral, ridges and clouds appear on surveys like pencil sketches of tides. In the more common case, where hydrogen is mostly ionized, the line fades, yet gaps and faint fringes still hint at boundaries where phases trade dominance. Deeper exposures trace streams peeled from companions, and high-velocity clouds that cut across the standard rotation with their own agendas. Kinematics at these wavelengths fill in the geometry without asking for starlight. Soft X-rays outline heat. A million-degree medium reveals itself in emission that is faint but everywhere. Sensitive imaging spectrometers measure temperatures by the shape of the spectrum and find specific ions of oxygen and neon that calibrate the state of the gas. The glow is not uniform. Cavities from old outflows, ridges from slow shocks, and arcs from mild compressions play across the field like memories written in pressure. Beyond emission, absorption of soft X-rays against bright background sources isolates even thinner layers. The outskirts become a palimpsest of heating events, each one catalogued by the ion that carries its thermal stamp. Gamma rays and microwaves add harder accents. Particles that run near light speed can upscatter low-energy photons into gamma light, marking regions where cosmic rays and magnetic fields cooperate. Microwaves, in turn, notice hot electrons through a spectral distortion they inflict on the background glow left by the early universe. Across large angles, this imprint hints at warm bridges between neighbouring concentrations of mass. The two bands together show that the periphery is not empty of energy. It is charged with particles and pressure that often move along paths set by magnetism as much as by gravity. The sky also hides rulers that measure through timing. Pulsars flicker with a steadiness that rivals atomic clocks. Their radio signals arrive dispersed, higher frequencies beating lower ones by measurable delays imposed by electrons along the route. The delay quantifies the total free electron column. One such column is a thin fact. Many such facts, placed carefully across the sky, draw a map of ionized gas that complements the picture assembled from absorption lines. Fast radio bursts extend the method to cosmological distances. Their sharp, bright pulses traverse filaments and halos, translating path lengths into dispersion measures that inventory the electrons outside the bright cities of stars. Lensing supplies a scale for mass without light. The outskirts warp the shapes of faint background galaxies by tiny, coherent shears. A single shear reveals almost nothing. Millions across wide fields reveal the statistical fingerprint of the halo. The signal can be stacked around many systems to trace average profiles beyond where stars and gas are comfortable. The transition from inner to outer regimes shows up as a change in slope that can be compared to theories of assembly and to estimates derived from the orbits of satellites. The method respects neither starlight nor temperature. It only listens to curvature of spacetime. Photometry at the edge finds needles in a hay of darkness by hunting specific stellar species that act as standard candles. Red, giant branch stars near the tip follow a well-behaved brightness. Blue horizontal branch stars hold another steady wattage. With careful selection, each can be used to detect streams and shells at distances that challenge other techniques. Their distribution uncovers break radii in the stellar halo and records the last stretches of arcs torn from long-digested dwarfs. These tracers also serve another task. Their chemistry can be resolved, establishing which features owe their origin to one family of progenitors and which to another. Spectroscopy of background galaxies broadens the quasar method. While their continua are less smooth, large numbers compensate for the noise. Stacking absorption along many lines of sight assembles the statistics of metals in the circumgalactic medium. Changes in equivalent widths with projected radius reveal where certain ions prefer to live and how far from the bright disk their populations remain strong. The profile is not merely radial, it is angular, reflecting the alignment with outflows along minor axes and with inflows near the plane of the disk. The map acquires arrows, not just contours. Timing and position metrology refine the kinematics into a clean measure of escape. Astrometric catalogues turn the slow drift of stars into precise tangential speeds. Paired with line-of-sight velocities, the three-dimensional motion of outer tracers calibrates the depth of the potential well. The distribution of speeds near the high end reads like a seismograph for the presence of dark matter at large radius. If the fastest bound stars top out at a given value, the curve of escape must pass above them. If a few exceed that value, a heavier envelope is implied. The data and the law dance, each testing the other's patience. New eyes in the infrared deepen the reach. Dust veils that hid the central bulge yield to longer wavelengths. Stellar catalogues become more complete near the plane where extinction once cut threads. In the outer disk, cold gas clouds glow faintly in rotational transitions of molecules that become visible to instruments that no longer fear ice and soot. The combined view tightens the budget of how much fuel reaches the inner city, how much lingers in the suburbs, and how much perches at heights where heating and cooling weigh their options. Surveys that tile the sky with uniform depth bring coherence to these threads. Wide-field cameras capture vast numbers of background shapes for lensing. Spectroscopic campaigns target millions of galaxies to fix their positions in 3 dimensions. Radio interferometers sweep large swaths for neutral hydrogen. Spaceborne observatories knit together ultraviolet and X-ray observations across many lines of sight. The instruments talk to one another through cross-matching and shared catalogues. The outskirts stop being a rumour. They become a shared object. Even silence contributes. Upper limits on emission in certain bands force models to choose between heating mechanisms. Non-detections of particular ions rule out temperatures that would otherwise be convenient. The absence of companions in certain quadrants trims the shape of the halo. The lack of curvature in a handful of streams restricts the influence of small subhalos that would have ruffled them. Constraints shape the coast as firmly as detections. The toolkit continues to grow. Arrays under construction aim to hear the faintest radio glows from diffuse gas and to weigh halos through lensing with finer noise floors. Detectors sharpen their timing resolution to catch more transients, whose dispersion will sketch new sightlines across the periphery. High-throughput spectrographs promise to turn thousands of background sources into absorption probes in a single night. Each improvement enlarges the margin where the edge can be read. At the rim, tools serve a modest ambition. They seek not a line but a field of thresholds. They record where gas changes phase, where stars thin to streams, where escape speeds sag toward openness, where metals stop being common, where heat ends in radiation rather than in expansion. The coast they draw is patient, laboured into being by photons counted one by one and by angles measured in fractions of a hair's breadth. Out there, precision is a kind of kindness, and the kindness returns a portrait of the boundary as a living system that instruments can touch, if not hold. Verification begins with a principle that refuses romance. Measure, disturb, repeat, and accept the result even when it resists the comfort of expectation. The outskirts submit to this discipline in fragments. Each test bears its own blindness. Each trial invites a blind spot to be filled by another eye. Together they outline a curriculum of doubt, where the border of a galaxy becomes a question answered in many dialects of light. Absorption conducts the first examination. A bright lighthouse far beyond the rim sends a smooth spectrum across the intervening dark. Along the way, ions in the circumgalactic medium subtract narrow colours with surgical precision. Oxygen in high stages of ionization prefers the heat of a 1,000,000-degree bath. Magnesium and silicon draw their marks at lower temperatures, where gas begins to consider condensation. Hydrogen leaves the subtlest bite, a whisper in the ultraviolet that demands clean windows in the air, and instruments that can sit above the weather. Each line carries a column density and a velocity. Stack many lines of sight, and a census emerges. The test is strict because it counts what is present along exact paths rather than what glows in every direction. Failures appear as missing metal at radii, where models predicted rich stocks, or as unexpected velocities that imply winds where only quiet rotation had been assumed. Emission supplies the counterpoint. A 1,000,000-degree medium radiates in soft X-rays with a spectrum that betrays temperature and hints at pressure. Maps appear with cavities, ridges, and arcs that speak of past heat and present balance. The trial turns on surface brightness that falls with radius until it flirts with invisibility. Long exposures answer the flirtation. When the glow runs too flat compared to prediction, theorists must reconsider the way energy leaks and mixes. When the glow steepens abruptly, the case for a recent outburst or for a cold front gathers strength. Every arc is a question about the last push that gas received and the last place it chose to rest. Neutral hydrogen offers cross-examination through its quiet radio line. The frequency is fixed by quantum chance. The sky is generous with available space there. Arrays survey the outskirts for streams and clumps. The puzzles come in several flavors. Some clouds move too quickly to belong to tidy rotation. Others appear where ionization should rule. Models are summoned to explain survival times, magnetic support, and the rate at which such clumps refill the inner reservoirs. The line serves another function as well. By splitting emission into velocity channels, it draws the outer rotation curve with a patience that light from stars cannot match. A flat curve at great distance becomes an argument about mass that remains invisible. Kinematics offer a bench trial for gravity. Stars and clusters in the periphery carry velocities that can be decomposed with enough patience and enough precision. Astrometry turns the slow drift of positions into proper motions. Spectrographs translate Doppler shifts into radial speeds. Distances complete the triangle. From these numbers, the profile of escape velocity and the slope of the potential can be inferred. The test targets the unseen halo directly. If speeds near the high end exceed what a luminous mass can hold, the verdict falls in favor of dark matter with quiet finality. If a claimed departure later proves to be a mismeasured distance, the court records a caution about error budgets that were too thin. Lensing writes a separate ruling whose authority rests on geometry rather than on emission or absorption. The outskirts shear the shapes of distant galaxies by angles small enough to hide in noise, unless many cases are averaged. Stack enough frames, and the shear field grows legible. The radial dependence of the effect encodes how mass declines with distance. A break in slope near a preferred radius hints at splashback. A slow decline that refuses to acknowledge a tidy edge argues for extended halos. No photon needs to be emitted by the matter under judgment. Space-time carries the testimony. An entirely different witness arrives as a pulse. Fast radio bursts and well-timed pulsars carry dispersion measures set by the number of electrons along the path. Line up a set of sources that pierce the periphery at various impact parameters. Subtract the electrons that belong to the interstellar medium inside the disk. Subtract the contribution from the intergalactic medium as best as models allow. The remainder weighs the ionized halo. A low remainder contradicts generous reservoirs. A high remainder forces models to place more matter in warm, transparent phases that do not glow. The technique trusts timing over brightness and adds a fresh ledger to the pile. Neutrinos enter with a humility that borders on arrogance. They ignore magnetic fields and pass through entire stars as if through fog. In the periphery they say little, yet they test the engines that feed the halo by constraining the rate of core collapse supernovae in the disk. Fewer explosions mean less mechanical input into fountains and winds. More explosions supply a larger budget for stirring and heating. Detectors that tick to the faint signatures of distant bursts help calibrate feedback that cannot be tuned freely without consequence. The outskirts feel this calibration indirectly, but the chain of logic is tight. Cosmic rays and gamma rays stage a trial about pressure that normally hides. When high-energy electrons find low-energy photons, they lift them into gamma light through simple collision. The brightness and spectrum inform the density of energetic particles and the shape of the radiation field they browse. If the periphery glows more than expected, a case opens for outflows that transport cosmic rays to high altitudes, or for turbulent reacceleration in the halo. If it glows less, the fields may be weaker or the escape of particles more efficient. The verdict then returns to the balance between heating from particles and cooling from radiation in a region where both matter and energy prefer to keep their heads down. Trials that involve chemistry speak to ancestry. Metallicities in halo gas tell of how many generations of stars have enriched the reservoir. Ratios among oxygen, silicon, and iron hint at whether short-lived massive stars or longer-lived progenitors dominated the ash. A profile that declines with radius fits a picture where inner regions have been fed by many cycles of birth and death, and outer regions by fresher inflow. A plateau far out suggests metals have travelled along winds or along filaments. Any mismatch between these trends and those predicted by simulations becomes a summons to revisit mixing, diffusion, or the history of inflow. Control experiments take the shape of analogues. Other galaxies of similar mass and type are measured with the same techniques. Do their outskirts radiate with the same signature? Do their absorption profiles fall with the same grace? Do their satellite kinematics demand similar wells? Agreement strengthens the claim that the methods are seeing nature rather than a quirk of a single case. Divergence invites a search for environmental differences, merger histories, or hidden biases in the instruments. The border learns humility by comparison. Error analysis receives a full hearing rather than an afterthought. Background subtraction in X-rays can invent or erase entire shells. Misclassification of stellar traces can fold foreground stars into halo catalogues. Distance moduli shift streams by tens of thousands of light-years when a single systematic creeps in. Radio side lobes masquerade as filaments if deconvolution stumbles. Lensing shape measurements require corrections for atmosphere, optics, and detector behavior that leave little room for carelessness. Each technique pairs its result with a frank confession of what could still be wrong. The confessions form a second map beneath the first, a map of trust. Simulations act as mock courts, where the laws are known and the outcomes can be measured without noise. Synthetic skies are drawn from numerical universes and pass through the same pipelines used on real data. Where the pipelines recover known profiles and masses, confidence grows. Where they falter, biases are exposed. In the outskirts, these mock trials often reveal how easily faint structures melt into backgrounds or how scattered sightlines can accidentally favor certain velocities. The practice tightens the grip on results secured from the real sky. Occasionally, a verdict refuses to align with any present theory. A stream bends without a clear perturber. A cloud survives longer than instabilities should allow. A satellite population displays a geometry too planar for random assembly. These anomalies do not break the method. They illuminate the next set of tests. Search for a dark subhalo that left no light behind. Add magnetic scaffolding and see if the droplet lives. Reconstruct infall along a filament that might have delivered satellites in a sheet. Each trial becomes the first line in the next proposal, and the boundary advances because it was pushed by surprise rather than confirmed by habit. When all witnesses have spoken, the frontier remains a field of probabilities. The tests organize those probabilities into contours. Inside one, the gas is likely to be warm and ionized. Inside another, streams of metal poor stars are likely to be common. Inside a third, escape speeds are likely to exclude most new departures. The edges of these regions rarely coincide. Their overlaps define confidence. Their gaps define future work. The court never adjourns. It rests between sessions while the instruments cool, the proposals wait, and the patient sky changes little, but reveals a fraction more with each hearing. The future gathers at the rim like weather that has taken an oath of patience. Gravity keeps its calendar, and two great cities keep their appointments. Across a few million light-years, the nearest large neighbor drifts inward with the calm of a glacier. Their approach is not dramatic to the eyes of a single lifetime, yet measured against the long durée of a galaxy, it is quick, certain, and full of consequence. The frontier that feels tentative today will be redrawn, then redrawn again, until the word boundary acquires a new meaning under a different sky. He pictures the first encounter. Halos touch before disks do, vast spheres of influence greeting one another with tides that travel outward at the speed of information carried by gravity. Streams already present in the periphery lengthen. Orbits of small companions tilt as if listening for instructions. The outer shells of both galaxies feel a tug that does not quite lift them free, but that shifts distances and speeds enough to matter. The splashback surface shrinks along the line of centers. The tidal limit contracts toward the saddle that forms between the two wells. The frontier breathes in, a prelude to contact. Then the first pass. Disks interpenetrate. Stellar collisions remain rare since stars are small and separations are large, but gravitational encounters multiply. Spiral arms buckle. Bars strengthen. Gas clouds slam into gas clouds and convert orbital energy into heat and shock. The outskirts answer in their own language. Shells of stars ripple outward like rings on a dark pond. Plumes rise from the plains. Faint and elegant. Each one a record of orbits that were stretched and then frozen in new parameters. The edge becomes decorative, a calligraphy of tails and umbrellas that sketch the balance of forces at the moment of disruption. Under the heat and the squeeze, reservoirs collapse into short seasons of wild fertility. Star formation in compressed lanes spikes. Young clusters crowd the bridges between the partners and paint them in blue. Supernovae follow quickly and return momentum to the larger flow. Outflows wake from the core regions and from the bridges, carrying metals and magnetic fields into the high altitudes. The circumgalactic medium fattens and warms. Cooling times lengthen far from the center, while condensation accelerates near the newly formed bars. The border shifts from a cool inflow regime to a hot, wind-swept belt. It does not retreat smoothly. It shivers in steps as bursts of pressure pass and fade. Between passages lies an interlude. The galaxies swing apart on elongated loops, slowed by the friction of tides that transferred energy to stars and gas. The frontier stretches again, but never quite returns to its initial shape. Material stands at apocenter in long arcs that define a new perimeter by default rather than decree. Some dwarfs are traded. Others are flung outward and left to decide if they are still citizens of the growing union. The zero-velocity surface of the entire association adjusts to the changed mass distribution. the plain between the giants becomes a valley. A second pass tightens the spiral, then a third, and eventually the cores sink through dynamical friction and merge. The central black holes circle each other within a common envelope. Over time, they shed energy into stars and gas, then into gravitational waves, until they join. The union shudders through the remnant as a memory of invisible ripples. The surrounding stars notice the recoil, however small, and the shape of the inner density profile edits itself once more. The outskirts, sensitive to slow changes in potential, readjust their orbits. Surfaces of equal energy settle into a new hierarchy. The frontier becomes a single volume of influence with a larger mass and a deeper well. The remnant takes on a shape that is neither the original spirals nor a perfect sphere. It relaxes into an elongated, slightly triaxial body with a thickened central envelope and long-lived shells. The new halo is heavier by the sum of its parts and by the prize of captured dwarfs. The virial radius grows as the mass and the declining background density cooperate. The splashback surface settles at a distance that reflects the recent accretion rate, which may be briefly high during the merger and then lower as the combined system pauses to digest its meal. The practical border for satellites expands in some directions and compresses in others, a three-dimensional footprint stamped by the memory of approach along a favoured axis. Gas finds a more complicated fate. The immediate post-merger state holds large amounts of hot plasma, raised to high entropy by shocks and mixed by turbulent wakes. Cooling proceeds, but not everywhere at once. Pockets rain filaments inward and form new disks or rings inside the larger envelope. Elsewhere, heat wins and the halo remains a reservoir that refuses to condense quickly. The edge of neutral hydrogen retreats and advances like a coastline under shifting winds. The ultraviolet background continues its quiet work of ionization, especially in the outskirts where density is low. The border that matters for starbirth is now an archipelago of cool clouds embedded in a sea of warm and hot phases, not a single radius that can be inked. The solar system, humble in this pageant, experiences a statistical fate. Its orbit around the common center changes slowly as the potential changes underfoot. Encounters with passing stars are likelier during the busier stages. A rare, close pass could perturb comets in distant reservoirs, sending messengers inward to the inner planets. Ejection is possible but not favored. The most likely story is continued, belonging within a reshaped domain whose horizon lies farther out and whose city lights appear redistributed across a thicker sky. Whatever its path, that path is one vote in the larger election that redraws the border. Once the remnant has settled, a new season begins, long and quieter. With fewer fresh infalls, the supply of cool gas diminishes. Star formation declines. The halo's metals continue to mix outward, but the gradient of enrichment grows shallow as time stretches. Outflows lose their vigor without strong triggers. Fountains cycle more slowly. The frontier becomes less noisy in X-rays and less busy in ultraviolet absorption. The boundary acquires the personality of a mature coast, with fewer storms, longer calms, and slow erosion of shells whose contrast fades under a rain of weak tides. Beyond the local town, the universe writes another change that the border must honor. The general expansion accelerates under a driver that behaves like a constant push woven into the fabric of space-time. Distant structures recede with growing haste. Streams of matter that once aimed for the group find themselves halted and rerouted along converging roads that still belong to nearby knots. The turnaround surface of the association stabilizes and then isolates. At late epochs, only the members already inside will remain in easy dialogue. The frontier that separates bound citizens from the wider sea becomes once and for all a fence drawn by geometry rather than by current events. As the background cools, the microwave glow that once bathed the sky in a soft relic light loses energy. One day its photons will be too weak for many detectors to register, but their influence lingers in earlier ages as a gentle bath that set baselines for ionization and for the thermal history of very thin gas. The outskirts continue to cool by line emission and by slow expansion, but without strong inflow they empty of the raw material needed to write bright new chapters. Red dwarfs take the long watch. Their frugal fires guarantee light for trillions of years, yet their births become rare as reservoirs dwindle. The border holds, yet it holds around a city that sleeps more than it sings. Black holes endure at the centre, and within the halos as remnants of massive stars. The central giant, swollen by the merger, will accrete sporadically from dying stars and from the drifts of gas left behind by slow winds. Each feeding writes a small echo into the halo, a mild outburst here, a faint bubble there, signatures that testify to a metabolism still functioning, but free of fevers. The frontier feels these whispers as slight changes in pressure that barely nudge the phase balance. It is enough to keep the atmosphere stirred, not enough to alter the coast. Over spans that outrun language, even stars exhaust their fuel. White dwarfs cool, neutron stars fade. Collisions between remnants may spark rare fireworks, but the rule becomes darkness layered on darkness. If protons endure, matter waits in thin halos around black centers. If protons decay, the weighting itself dissolves and leaves energy to drift outward as cold light. None of this drama changes a simpler lesson the border has been teaching. An edge is not a cliff of substance. It is a set of behaviors that prefer one side to another, modulated by mass and time. He lets the far view come into focus. A single, larger halo rings a composite city whose outlines owe nothing to nostalgia. Streams that once traced a fragile rim have been folded into shells faint as breath. The virial measure marks a deeper well. The escape curve rises. The zero-velocity surface encloses a stable parish of stars that no longer expect visitors from far roads. The frontier stands there, a patient frontier, still porous to light and to thought, yet firm in the way a horizon is firm to sailing ships that will not cross it. Under that horizon, inhabitants look up and see a sky unfamiliar in detail, yet faithful in principle. A smear of merged light replaces the thin river of a spiral plain. The high arcs of shells add ghostly brushstrokes. The outer lights are fewer, because the universe has placed its distant cities beyond an ever-widening gulf. Or survives. It simply changes register. The border, once a trembling question about where home ends, becomes a whisper about how belonging matures. In the end, the coast remains, and the world within it learns to take its time. Night returns without ceremony, and with it a clarity that lives on the far side of spectacle. A single city of stars hangs inside a quiet volume, light cupped by a weight that seldom glows. Around that lantern, gradients replace walls, customs replace borders, and probabilities replace decrees. The edge is not something to cross like a gate into a neighbouring field. It is a change in behaviour, an altered grammar of motion, temperature, and light, a shore where meanings evolve. He holds the galaxy at arm's length in thought until it fits like a coin between finger and thumb. The disk is a pale river. The bulge is an ember. The outskirts brighten only where memory persists in streams and clusters. Beyond these, gas keeps its counsel, hot or warm, sometimes condensing into pearls that drift inward, sometimes remaining a transparent sea. Dark matter spreads wider still, a hush with the authority of mass. The picture does not harden into a contour. It settles into a portrait of tendencies. Inside, stars fill volumes and orbits close with confidence. Outside, matter visits and lingers, then yields to a larger conversation. The conversation includes gravity, that old scholar, and heat, that chronic traveller, and radiation, that courier who never tires. They speak in lines on spectra and in the subtle curvature of background shapes. They sketch distances, speeds, and temperatures that fit together in a jigsaw thick with sky. From those pieces, a border appears that prefers honesty to sharpness. The map carries labels that are also questions. Virial measures offer one radius. Tides propose another. First opposenters carve a third. Chemistry adds shells. Escape speeds thread through them all. The sum is an estuary, not a fence. He listens to smaller citizens whose stories turn the abstract into touch. A solitary cluster swings through high latitudes, each star within it old, each orbit a vote for belonging that never quite reaches the ballot box. A faint cloud glides with more speed than comfort allows, a remnant of a river that seems too delicate to endure. A single star runs like a thrown stone, its future out among breaths of gas that avoid condensation, and among distances where expansion has a little say. None declares an edge with authority. Together they mark an approach to one. Instruments watch these motions and pains with a patient tenderness that resembles devotion. Photons are counted like beads, each one threaded on strings that cross the periphery and remind the mind that the night is a ledger. Lines deepen where gas is thick. Lines vanish where it is hot and spare. X-rays write a soft glow that refuses to lie about pressure. Radio whispers reveal hydrogen when it chooses neutrality. Lensing adds a weight without light. Timing turns pulses into columns of electrons. The border answers to all these hands, not as a confession, but as an acknowledgement that truth here is cumulative. He considers the word home and finds that it carries more rooms than he guessed. Home is a disk with seasons of starbirth and long winters of waiting. Home is a halo that keeps the city in coherent company. Home is a road into a larger structure that refuses to admit loneliness. The threads of the web trail into the dark, like paths through fields at dusk. They feed, they receive, they tilt the outskirts, so that orbits and flows align with history that began before any lamp was lit. The border in such a place cannot be a line. It must be a habit that space has learned, a tendency that mass rehearses. Memory arranges this into a final shape. The galaxy learned its form through patience and events. Streams are not decorations. They are signatures of meals that left marks on a face that ages slowly. Hot envelopes are not wastes. They are banks that keep capital at interest and pay out when cooling permits investment in new light. Outflows are not loss. They are the breath that keeps lungs flexible. Inflows are not gifts from nowhere. They are obligations fulfilled by a structure that is larger than any one member. The edge is where these trades come to terms. It moves because the economy moves. It will move again. He lets the mind's camera retreat until the city becomes a fleck within a dim braid of filaments, and even the braid grows thin against a depth that has little to say. Silence at this scale is not indifference. It is permission that allows smaller voices to speak. The galaxy's boundary, read this way, is a margin given by the night to a story that needs room. That margin supports invention, not the humankind alone, but the invention of patterns that physics allows. In such invention, mystery does not hide. It participates. It offers itself as structure. There is comfort in this that does not depend on knowing everything. Precision increases, maps are redrawn, machines learn to hear fainter songs, and the shoreline becomes more legible. Yet the feeling that matters survives the updates. The border is real as a weather front and elusive as a thought halfway to speech. It is a place to stand and to listen for how matter chooses to belong. It is a school for humility where definitions are provisional by design, yet still useful enough to steer. He takes one last inward step and imagines a night under that river of light, eyes raised, breath held. A person stands not at the center of anything, yet at a crossroad of many scales. Thought stretches past the last bright stars and into regions that do not care for sight. Instruments extend that reach and return with stories the senses could not gather alone. Those stories end here, at a coast that keeps changing and yet continues to serve. From it, awe departs renewed, now seasoned with the discipline of measurement and the patience of slow time. A boundary, then, is where understanding begins to lean into wonder. It is the bracket that invites a sentence to continue, the margin that invites a note. The Milky Way holds such a margin with grace. It does not barricade the mind. It does not abandon it to blankness. It draws a gradient that becomes a path. That path leads outward, yes, but it also loops inward, where the definitions that matter most are those that allow a world to be both local and immense, both held and open. The night allows the last word, and the last word is not an answer. It is an acceptance that this coast will never be finished. Instruments will return and redraw. Stars will move and rewrite. Gas will rain and rise. Dark matter will keep its quiet authority. The map will gain detail, and the feeling of standing at the rim will remain a human constant that does not require a final line. The journey beyond the boundaries of the Milky Way ends by disclosing that boundaries here are ways of seeing, and that seeing improves when it learns to love thresholds. Night folds the map and leaves the hand empty, not from loss, but from a gentler fullness. A city of stars glows like a thought that refuses to fade. Around it, gradients breathe, tides whisper, and the patient hush of dark matter steadies the scene. The edge does not slam like a door. It opens like a window, the pane cool to the touch, the outside air thin and clean. He stands before that window and feels the long weather of space move through him, a wind of ideas, a current of time. Distances become instruments rather than obstacles. A single stream writes history with the calm of a creek through grass. A single cloud rehearses survival in a sea that would prefer it dissolve. A single star chooses a hard path and proves that laws are generous when read carefully. Above these particulars, the galaxy keeps its tone. It breathes, it trades, it listens to the web that serves it, and it grows old without growing dim in meaning. The border is the page margin where all this can be read. There is nothing to conquer here, only a practice to continue. Count what can be counted, weigh what bends light, time what crosses distances, and admit the rest into the circle of wonder without shame. Let the map be charcoal, not ink. Let the coast be patient as a tide. The night will reward that courtesy. It will return photons that travelled longer than civilizations, and it will keep safe the delicate signatures of atoms that never knew a name. He leaves the window open. Air without air drifts in, and with it a quiet that feeds thought. The galaxy rests within that quiet like a lantern in a field. The field widens, the lantern holds. The edge stays kind. Sleep comes to the watcher as a friend, and the sky keeps watch for both.